Welcome to this course on full stack development. You've come a long way with all the other courses you've completed in the Backend Developer series. Like in the previous course about APIs, you delve deeper into the processes and concepts behind APIs and their infrastructure. And now you probably want to know what lies ahead with this course. Let's begin. Full stack is about end-to-end application software development. That means that as a full stack developer, you will be involved in every step of a project. Take, for example, the Little Lemon restaurant that you've been working with throughout the courses. The restaurant has a home page with menu items that customers can browse and order by adding items to their cart. This process requires a front-end infrastructure and some business logic written in the back end. And the back end also connects the application to other services like databases. As a full-stack developer, you will be able to implement every part of this project. Now, let's move on to the content the course will cover to make sure you're ready for such an endeavor. Module 1 offers an introduction to the full stack and what a full stack developer does. This entails learning about the roles and responsibilities of a full stack developer, as well as making sure you understand end-tier architecture. Module 2 is all about front-end technologies like HTML, CSS, and JavaScript. Some of the key concepts you'll learn about are semantic HTML and basic forms, CSS and responsive layouts, and how to update an HTML document using JavaScript. Then you'll move on to learn how to use Django with the full stack, and you'll get an opportunity to build a full stack application using Django. That sounds like valuable knowledge. You'll discover how to populate Django models for a MySQL database, query an API, and update an HTML document with the result. In Module 4, you will learn about production environments. For example, you'll explore the different environments that web applications are deployed to, and you'll learn about the different hosting solutions available for your web applications. Very importantly, you'll also learn about the cloud computing environment that can make your life easier in several ways. Lastly, you will cover the challenges of scaling web applications. After all of this, you will be ready for the final project, which consists of several labs that will help you put together the skills you learned in the course and implement your code in the full stack. The labs include connecting the Little Lemon restaurant backend to MySQL, setting up a booking API for the restaurant, and lastly, displaying Little Lemon's available booking times. After this hands-on learning, you will have to complete one final graded assessment, but be assured that everything you need to do for the assessment will be covered during your learning, with each lesson made up of video content, readings, and quizzes. There are many videos in the course that will gradually guide you towards your goal of becoming a developer. Watch, pause, rewind, and rewatch the videos until you are confident in your skills. Then consolidate your knowledge by consulting the course readings and putting your skills into practice during the course exercises. Along the way, you'll encounter several knowledge quizzes where you can self-check your progress. And remember, you're not alone in considering a career as a developer, which is why you also work with course discussion prompts that help you to connect with your classmates. It's a great way to share your knowledge, discuss difficulties, and grow a network of contacts in the development world. To be successful in this course, it's helpful to commit to a regular and disciplined approach to learning. Although this is an online self-paced course, you need to be serious about your studies and, if possible, map out a study schedule with dates and times that you can devote to attending the course. In summary, this course provides you with a complete introduction to full-stack development, and you'll have the opportunity to build a new application using your developer skills. This will set you on your way towards a career in full-stack development. Looking forward to accompanying you on your learning journey.
I think one of the biggest shockers for people is that the stereotypical engineer is someone, in a dark room with a computer hunched over, typing on a keyboard. But when you go into software engineering, especially in corporate setting, there's a lot more communication, collaboration, talking to people, being able to figure out what you have to build and do it with people is just so much more bigger than people think. My name is Des. I'm a software engineer, and I work in the Meta office in DC in the integrity organization. So you obviously have to build software since that's the job. But because of Meta's bottoms-up culture, a lot of times you have to align with various teams across the company. So we spend a lot of time in actually writing out what you have to build, design documents, and sharing it with other teams and getting feedback so that we build stuff that everyone is sort of on the same page with. So you always have to make sure that everyone is aligned with the same objective. When you do good work, people have to know you do good work. So a lot of time is spent on written communication. So you have to usually write notes and stories about what you're doing so that other people can know what you and your team are doing as you work on those projects. The programming language I work with mostly is called Hack. Unlike other languages, we don't expect anyone that joins the company to know it already. So we have that buffer built in for you to learn and get up to speed. Almost a good thing that no one else uses Hack because everyone that joins the company is on the same equal footing versus like something else that someone else may know already before they join. So we have to be able to move fast, but also balance that with our existing user base and products. And what ends up happening is that there's just a ton of overhead in terms of communication that you have to do to make sure that everyone is on the same page and you don't do anything that may have a negative impact. So it's good because you get to interact with a lot of different people and learn a lot, but it causes challenges just because, like I said, there's a lot of extra stuff you have to do for every little change. So just trying to balance that risk and still be nimble and fast is something that I think is a big challenge. Being able to look at problems and break them down and then break them down into something that is more manageable and solvable is one of the things that I have to do day to day. Something else that is to scale yourself. So a lot of times problems are too big for one person, and we have to learn how we can sort of like work together with people in our teams and in external teams to basically achieve these bigger problems in an efficient way. And that's something that I think, for our engineers, we definitely value in terms of what they can do. I would say every software engineer is expected to grow into a leader. One of the things you see in Meta is we have sort of like a career progression for engineers, and I think most companies do also. But the idea is that when you graduate from college, you start in at the first level, and when you start in initially, you're doing more task-based work, whereas people give you tasks and you get it done. And as you grow in your career, you begin to have more initiative and have to drive more projects. So you go from, hey, do this task to, I'm going to find work to do and create tasks and do them myself. And then you go to, I'm going to find work to do and give tasks to other people and help them grow in their career. I hope that you take away that being an engineer is something that can be very fulfilling. So I would say, even though it feels difficult initially, I would say to stick with it and see how things go at the end versus like giving up too early, because the sort of like end result could be something that you wouldn't even imagine. Good luck for the rest of the course, and hopefully I'll see you in the industry someday in the future.
Welcome to the Full Stack course. In this video, you'll learn what full stack development is, what a full stack developer does, and why it's an in-demand role in today's job market. You might find yourself wondering what stacks are. They are a combination of software, applications, and components you use to fix a problem or create a project with a certain development focus. For example, there's the front-end stack that's mostly focused on the user interface. Developers use different tools and programming languages, like HTML, CSS, and JavaScript, to build the front end of web and mobile applications. And together they are the front-end stack. On the other hand, you build the back end of a web application, which is mainly the app's core, with another set of programming languages and tools which include Python, Django, and DRF. And these comprise your back-end stack. The back-end stack also includes a data management system that consists of database applications to process data. This is generally referred to as the data stack and is part of the back-end stack. Let's examine these three stacks in more detail. The back-end stack has everything you need to create the back end of an application's core. That deals with business logic, workflows, and data. Back-end development includes programming languages like Python or JavaScript, frameworks like Django, and utilities like DRF, and also builds tools, databases, and caching applications. Let's shift the focus to the front end, which has two distinct parts, web and mobile. This stack includes everything you need to create a functional user interface of a web or mobile application that can communicate with the back end. To build the front end of a web application, you need to learn HTML, CSS, and CSS frameworks. You also need to know about client-side programming languages like JavaScript or TypeScript, and JavaScript frameworks like React. And lastly, you also have to be familiar with either iOS or Android development tools, or both, for mobile application development. Now let's move on to the data stack. One of the most crucial parts of every application is the data stack or tools you use to successfully store, process, and retrieve data. This stack contains SQL or NoSQL database engines, caching tools, and everything required to process data. In fact, MySQL, MariaDB, and PostgreSQL are some of the most widely used database engines you can learn to use for data stack. For caching, Redis is a popular and widely used solution. Finally, let's discuss the full stack, which is the end-to-end solution for an application. It contains everything you need to create the application's core or the backend, process the data, present it via APIs on web or mobile applications. A full-stack developer is equally skilled in the backend, front-end, and database stacks. Such a developer should have some essential DevOps skills to build and deploy an application to production, staging, and development servers. To be a full-stack developer, you must learn everything that is required to create and deliver a functioning application. And you must also be familiar with a version control system like Git for full-stack development. It takes time to be a successful full-stack developer, so you'll have to be a little patient with yourself. But what exactly are a full-stack developer's responsibilities? A typical full-stack developer performs the following tasks: understand the complete project and take full ownership, select appropriate tools for developing the front-end, back-end, and database, create effective user interfaces for web and mobile applications, develop APIs, develop the back-end of applications, store, process, and retrieve data from databases, create servers and manage them for development, staging, and production access, integrate with the CI/CD workflows, ensure the responsiveness of web applications, work together with the graphics team to bring their ideas to life, optimize applications for maximum performance, and make sure applications follow the best security practices. That's quite a lot of responsibilities, so you now understand why some patience is needed to learn all of these skills. But don't worry, with hard work and dedication, you'll get there. In this video, you learned about different stacks in the application development process. You also learned about full stack development and the role of a full stack developer. When you develop an application, it has different parts. There's the UI, backend, business logic, and database. These parts need to properly communicate with each other to make an application work. In this video, you will learn about some common architectures used in modern application development. Let's start with layers and tiers. In application development, you often hear the terms layers and tiers being used interchangeably. But there's a difference between them. As you learned earlier in the course, an application can have multiple parts, like the presentation part, the core of the application where the business logic stays, and the database. When these parts are in different places in the application infrastructure, like on different servers, but they still communicate with each other and function correctly, they are called tiers. Thus, layers are virtual separations of different parts of an application. Tiers are also different parts of an application, but they're physically separated in the application infrastructure. Now let's discuss N-tier architecture in two types, 3-tier and 4-tier architecture. In modern application development, there can be any number of tiers. When an application's architecture is split into multiple tiers, it's called an N-tier application. These days, 3-tier architecture is the most commonly used N-tier architecture. Some developers also use a 4-tier architecture when required. Let's say you developed a web application and the application is split into two distinct parts, the code with business logic that processes the data and the database to store the data. You host the application code on one server and the database on another. Since they are physically separated into two different servers, you can call them tiers. In this example, there are 2 tiers. So where's the third one? The third tier is the client computer or mobile, which is used to browse a web application or access the APIs. These clients are completely separate physical machines. So together, the client machine, your application server, and the database server make up a 3-tier architecture. In a 3-tier architecture, the client tier is called a presentation tier. Client machines are also called thin clients because they don't run business logic. They only communicate with your application and present the data. The tier that holds the application code or business logic is called the application tier. And finally, the tier that deals with data is called the data tier. So the three tiers are presentation, application, and data tiers. Let's move on to the four-tier architecture. In a web application with a four-tier architecture, a fourth tier is included called the delivery tier. This delivery tier deals with caching and delivering the front-end assets to the client. For example, like a content delivery network or CDN. CDN providers have many servers across the world for better content delivery. They store your web application's HTML, CSS, JavaScript, and images and deliver them to the client from the nearest server. Because CDN servers are physically separated from your application and data tiers, they're seen as another tier, the delivery tier. This is just one example of a four-tier web application, and these applications can be very different from one another depending on their purpose. Like, for example, financial or enterprise applications that have different needs. There are several benefits to an N-tier architecture. Let's examine some of them now. When the application is divided into multiple tiers, it becomes easier to secure and scale the application. And fixing problems or adding new features becomes more manageable because each tier is separate and works independently. Thus, the application development process becomes more efficient when you use an N-tier architecture for your application. In this video, you learned about the difference between layers and tiers. You also learned about the popular N-tier architecture and how to use it to create a 3- or 4-tier architecture for your web applications. You've reached the end of Module 1 that gave you an introduction to the full stack. It's now time to review what you've learned in these lessons. You began this module by exploring how full-stack development works in the real world. Meta Software Engineer Manager Des Udezu walked you through a day in the life of a full-stack developer. After this, you reflected on what you hope to learn from this course, and you familiarized yourself with the course syllabus to orientate yourself. You also read some suggestions on how to be successful in this course. This included tips like setting daily goals, scheduling time to study, and making sure that you remember to take regular breaks. The last one might seem like the least important, but to be able to focus and work to the best of your abilities, you need to make sure that you're well rested and energized. After this reflective first part of the course, you explored the different stacks, namely the front-end, back-end, and data stacks. You learned about the programs and tools used in these stacks, such as Python, Django, and DRF, which are used for developing the back-end. You now know that the full stack contains everything you need to create an application's core, or the back-end, process the data, and present it via APIs on web or mobile applications. And you learned that the full stack is an end-to-end solution for an application and that a full stack developer is equally skilled in the back-end, front-end, and database stacks. Furthermore, you learned about typical full stack developer tasks such as developing the back-end of applications, storing, processing, and retrieving data from the database, and creating servers and managing them for development, staging, and production access. Next, you learned about N-tier architecture. This is when an application's architecture is split into multiple tiers. The benefits of N-tier architecture are that it's easier to secure and scale an application and fix problems or add new features. Fixing and adding features are more manageable because each tier is separate and works independently. You learned about the two types of N-tier architecture, namely 3-tier and 4-tier architecture. You learned that in a 3-tier architecture, the 3 tiers are presentation, application, and data tiers. Whereas in a 4th-tier architecture, a 4th tier, namely the delivery tier, deals with caching and delivering the front-end assets to the client. Lastly, you reviewed what you know about client-server architecture. For example, you reviewed the components of a client-server architecture as well as the roles of the client and the server. Congratulations! You've now covered the introduction module of this course and you are ready to complete the quiz. In the next module, you'll learn about front-end technologies including HTML, CSS, and JavaScript.
The average person doesn't know much about what happens behind the scenes when they browse the internet on their phone or computer. But as an aspiring developer, you are aware of how the content on screen is controlled by HTML and CSS. And by now you know that HTML is a markup language used to create web pages. In fact, it's the most basic and fundamental language for creating web pages. And together with CSS, it has helped the web browser expand beyond just desktop computers. HTML has been around since 1990, and it was originally designed to provide a way for people to share information over the internet. HTML web pages used to only show basic images and text. The websites you browse today are very different. This is because HTML can do much more than just defining how content is displayed in the browser. HTML is great, but together with CSS, it can do so much more. CSS is a style sheet language that is used to describe the look and layout of a document written in HTML. While CSS is not a programming language, it does allow for some programming-like features such as variables and nested rules. And what it does is give you control over color, size, spacing, fonts, positioning, and more. One of the fundamental principles of CSS is the separation of content and style. That means you can change a web page's appearance without editing its underlying HTML. W3C, the organization responsible for standards for the World Wide Web, manages both HTML and CSS specifications. They continually improve their capabilities to ensure that they are always oriented towards current requirements. Many new features were added to the current version of HTML that make it easier to use than previous versions. These are better support for multimedia content, such as audio and video, improved support for responsive design, such as adapting the web page layout depending on the device the web page is viewed on, new form input types such as sliders and range inputs, date and color pickers, new form validation features, and new ways to work with text, such as spell checking and text editing. Some major additions released for CSS in 2011 ensure that CSS can style and control a website regardless of the media content or the device used for viewing the page. The additions to the current version are media queries, which allow for different styles to be applied depending on the device being used, box sizing, which allows developers to specify how they want their content to be sized and padded, multiple backgrounds, which mean you can specify multiple background images for an element, border images, which allow developers to specify an image as a border instead of a solid color or style, text shadows, which mean you can add shadows behind text for a more three-dimensional look, and transformations and transitions, which allow developers to animate elements on a web page. In essence, the combination of HTML and CSS allows websites to adapt their design and layout based on the devices on which they're viewed. While this feature was initially used to support mobile devices like cell phones and tablets, the usage of HTML and CSS has grown beyond the traditional web browser and web pages. Today, web pages can be viewed not only on computers, cell phones, and tablets, but also on video game consoles and even smart TVs. The web browser has truly expanded beyond traditional desktop devices, and it's all thanks to the combination of HTML and CSS. By now you know that HTML describes the content of a web page, but how do you describe the meaning of a web page? To understand this in a real-world context, think of buttons in an elevator. The vertical arrangement of buttons isn't enough for someone to understand their meaning. To convey the meaning or semantics of the buttons, numbers are added so that people know which button will take them to which floor. When you write HTML, it's good practice to semantically describe the content. This allows search engines and accessibility software, such as screen readers, to understand the contents of a page. Fortunately, you can do this by using some basic HTML tags. For example, using a heading tag such as H1 describes that the content is a heading. Similarly, the UL and OL tags describe lists. However, there are many more semantic HTML elements available to you as a developer. In this video, I will share a structured approach you can take to make sure that you create a well-formed web page. Let's revisit the basic structure of a HTML page, which includes the head and body. Inside the body tag, you can lay out the website with various semantic tags to describe each of the sections. For a typical HTML page, the structure can be semantically described using the header, main, and footer semantic HTML tags. For example, suppose you lay out your page with a header section that contains some company logo and navigation links. Then a main section contains sections and articles. Finally, a footer section contains contact information and social media links. The main navigation section of your web page can also be described semantically using the nav tag. Depending on how a web page is designed, the nav element is often placed after the header element, and the header element is used for logos. The main links of your website are then added inside the nav element. It is common practice for developers to specify their links as an unordered list inside the nav element. Next is the main content of a web page. The two key semantic elements for your main content are the article and section elements. First, let's examine the article element. The HTML specification states that, according to the World Wide Web Consortium's website, the article element indicates content which represents a complete or self-contained composition in a document, page, application, or site that is independently distributable. That's quite a mouthful. It may help to think of a page in a newspaper. There are many articles on the page, and you can cut out the individual articles with scissors if you want to. The articles you can remove are like the article element. Examples of this include a forum post, a magazine or newspaper article, a blog entry, a user-submitted comment, an interactive widget or gadget, or any other independent item of content. Let's examine how the article element is used. Say you are developing a blog about your summer holiday. It's good practice to contain the blog post content inside of the article element because it's a complete self-contained composition on a web page. You should place the article element within your main element. Then you add your regular heading and paragraph tags inside the article element. The reason for doing it this way is because the main element semantically represents the main content of the page. And inside of it, there can be multiple article elements for something like a blog post list. At the end of your document is the footer element. This might contain additional navigation links or other content. It is important to note that semantic elements are not limited to this structure. Since their purpose is to describe the semantics of the content, the elements can be nested inside of each other if it accurately describes the content. Let's update the previous example to use a nested semantic structure. You add a header element to the article element. Inside the header element, add the heading element with the blog title and a paragraph element describing the date and author of the blog post. Inside the main element, add the content of the blog post. That's it. Let's examine the section element. You can add a section element to semantically define individual sections of the article. It is important to note that sections should contain heading elements to semantically describe the section. It is also possible to use section elements to describe different sections of your web page. The section element doesn't require the article element. It all depends on how you want to semantically describe your page. And now you know how to semantically describe the contents of a web page. Your web page is more accessible because the content is semantically described to add meaning. Now search engines and accessibility software can easily understand the contents of your well-formed web page.
When a team of builders begin constructing a building, one of their key tasks is to assemble the frame. It doesn't matter what kind of building it is. It always starts with a frame of beams and rafters. Once in place, the frame guides the rest of the construction. If you compare a building with a web page, an HTML document is a lot like the frame. It's a basic structure assembled with different components such as tags and elements. In this video, you will learn about HTML documents and the difference between HTML tags and elements. To begin, let me tell you a short story about where it all started. So Tim Berners-Lee, a physicist, often thought about how he and his colleagues from around the world would share information. You were so used to browsing information online that it might seem a silly thing to ponder about. Actually, that question was very relevant at the time and started the development of HTML. Would you like to explore the very first web page? I know just where to find it. The first web page was created in 1989 by Sir Tim Berners-Lee. He worked at the European Organisation for Nuclear Research, or CERN, and originally proposed HTML. The first version of HTML was released in 1991, along with the first web browser and web server. HTML stands for Hypertext Markup Language. But what does that mean exactly? Hypertext is text which contains links to other text. Markup refers to tags and elements used within a document. For now, let's just focus on some of the basics of HTML. HTML is simply a text file with a specific structure that consists of elements and tags. Also take note that HTML files usually have a .html suffix. For instance, when you visit a website, the first page that is returned to the browser is often called index.html. Now, let's explore what HTML tags and elements are. Each HTML element consists of an opening tag enclosed in angle brackets. For example, to create a paragraph, you type a left angle bracket, the letter P for paragraph, and then a right angle bracket. Most elements are paired with a closing tag, which has a / after the left angle bracket. For example, you close a paragraph element with a left angle bracket, a /, the letter P, and a right angle bracket. HTML elements usually have some content inside them. For example, between the opening and closing tags of a paragraph, you add the text of the paragraph you want to write. HTML elements can also contain other elements. For example, you can add an italics element inside a paragraph element to make text appear in italics. But elements can also be empty or self-closing, meaning they do not have a closing HTML tag. One example of a self-closing element is the line break tag. You can add a line break tag in a paragraph tag to move content to the following line by typing left angle bracket, the letters BR, then right angle bracket. At the end of a self-closing tag, you simply add a right angle bracket, but you can also close the right angle bracket by typing a / right before it. Now that you know what elements and tags are, you will explore what HTML standards are. The rules and structure for elements and tags are known as the HTML specification. The HTML specification is maintained by the World Wide Web Consortium, or W3C as it is commonly known. Whenever the HTML specification changes, a new version of HTML is standardized. The current version is HTML5. So to summarize, HTML elements with their opening and closing tags in angle brackets build up an HTML document. These elements form the structure of a web page and describe to the web browser what to display. For example, the browser reads an HTML page that has an image tag to display an image file called icon.png. Next, it reads a P tag to display a paragraph under that image. But the browser reads the HTML document and displays the web page to the user in a very basic format. Now, if you want to tell the browser how to display the web page, you should use CSS. You will learn more about CSS in this course. By now, you have learned how HTML tags are used to create elements that build the structure of a web page. You'll have an opportunity to explore HTML in action in this course.
The Little Lemon restaurant has asked me to add a new blog page to their website. They've told me that the page will contain several blog posts and that it must use semantic HTML so that search engines and accessibility software can understand the semantics of the page. I've set up my basic HTML document structure in a file named blog.html. I'll start off by adding my basic semantic structure. First, I add the header element, followed by the nav element, followed by the main element, followed by the footer element. Remember, this structure describes the semantics of this HTML document. Specifically, the header element will be used to display the Little Lemon logo, and the nav element will be used to describe the navigational structure of the website. The main element will feature the main content of the web page, and the footer will be used to display copyright information. When a search engine or accessibility software reads this document, the semantic tags will help the software understand the purpose and meaning of different sections of the document. I will now add the details to each element. Inside the header element, I add the Little Lemon logo using the image tag. Inside the nav element, I add the navigation links in an unordered list element using the UL tag. I then add 3 list item elements using the LI tag. Inside the list items, I add the hyperlinks for index.html, location.html, and blog.html using the anchor tag. In the main element, I add an h1 tag for the blog heading. The restaurant told me that there will be 2 blog posts for their website, so I add 2 article elements after the h1 element. Inside the first article element, I add an h2 tag for the title of the blog post. The title is 20% off this weekend. I then add a paragraph element below the title, which contains the blog post text. Inside the second article element, I add an h2 tag for the title, which is Our New Menu. Again, I add a paragraph element below the title, which contains the blog post text. Finally, I add a paragraph element to the footer element. In this paragraph element, I add the copyright notice. The blog page is now semantically described through the HTML document. I now save the file by pressing Ctrl and S or Command and S on Mac. I then right-click the blog.html file and select Live Preview to preview the file. The blog page looks good, and all thanks to proper semantic design that ensures accessibility and search engine optimization. I'm sure that the Little Lemon restaurant will get lots of business through their blog, and their customers with disabilities will be able to access the blog with no problems.
You've most likely encountered forms when registering an account on a website or when filling out your address for something you've bought online. As a developer, you'll use HTML forms to capture user input. Capturing input is one thing, but the form also needs to ensure the data is usable. How can you ensure the user input is valid? For example, let's say you are building an online food delivery website. Say a user accidentally makes an error when entering the delivery address and the form accepts it, although the location does not exist. It will cause a very bad user experience when the food never arrives. This is where form validation comes in. Form validation is a process that ensures that the data entered by the user in a form is valid and conforms to rules defined by the developer. There are 2 methods of form validation: client-side validation and server-side validation. Client-side validation checks for errors as soon as they are typed into the form. This is done by the web browser or by JavaScript code and provides the user with immediate feedback. The client-side validation process starts by checking if a form has been filled out correctly. If there are no errors, the form will be submitted to the server for processing. However, if there are errors, an error message will alert the user of the invalid data and how to change it for successful submission. For example, you decide to use the input element with its type attribute set to email. If the user does not enter a valid email address, the web browser will display an error message informing them that the data they entered is not a valid email address. On the other hand, server-side validation checks for errors after the data has been submitted to the web server. Server-side validation is more secure because it prevents malicious users from tampering with your website's code and submitting invalid data to your server. When the form data is received by the web server, the backend will validate the data before processing it. This validation can run more complex checks, such as checking the data against a database or validating the data against business requirements. Most websites use both client-side and server-side validation to provide immediate feedback to users, but also to protect against malicious data submission and to ensure data integrity. Let's examine how HTML allows you to do simple client-side validation. HTML has several input types that are validated by the web browser. As demonstrated in the example, email is used for email addresses. Others include tel for telephone numbers, URL for URLs such as www.meta.com, date for date values, time for time values, number for numeric values, range for numeric values which have a minimum and maximum value, and color for color selection. Say, for instance, a user makes mistakes on a user account form when entering a telephone number and a URL. The browser will validate the entered data against the requirements of the input type and provide user feedback. Another example is the required attribute, which indicates that the user must supply a value to an input field. The web browser will alert a user if a required value is outstanding. And that's the basics of client and server-side validation of forms. You'll learn more about HTML validation capabilities later in this lesson. When ordering products online, you fill out your address and your credit card number. Then you click on an order button that confirms your order. Because you are learning more about front-end development, you might be wondering what exactly happens when you click on that order button. In this video, you will learn what happens when forms are submitted in the web browser. By now, you know that the web browser communicates with a web server using a HTTP request response cycle. This means that the web browser sends requests to the web server and the web server sends back a response. Up to now, the main type of requests you've been introduced to were for resources such as HTML documents, images, CSS files, and JavaScript files. But it is also possible to send data as part of a request. This is how forms send data to the web server. In fact, there are two ways a form can send data to the web server, using the HTTP GET method or the HTTP POST method. You can specify which method the form should use with the method attribute of the form element. Let's examine an example form and see how the data can be sent using the two different methods. This login form accepts a username and password. It also has a login button that submits the form to the web server. So how would it work if the method attribute is set to GET? When the login button is clicked, the form data is sent as part of the request URL. This means that the user data is appended to the end of the URL in the web browser navigation bar. The web server receives the HTTP GET request and extracts the form data from the URL. While this is an easy way to submit data, it has three key problems. First, the length of a URL is limited to around 2,000 characters depending on the web browser you are using. Some web browsers allow more, but there are inconsistencies between browsers. So, if you have a large form, some data may be lost when it's sent via the GET method to the web server. Second, the length of a requested URL is also limited on some web servers. Popular web server software such as Apache Web Server or Nginx have a default limit of around 4,096 characters. So again, if you have a large form, some data may be lost. The final problem is security. Since the data is included as part of the URL, it means that your data is stored in your web browser history and possibly in the request logs on the web server. If you're transmitting personal information such as addresses or credit card numbers, this is a major privacy and security risk. Now let's focus on how the form would work if we set the method attribute to POST. When the form is submitted using the POST method, the form data is inserted into the content of the HTTP request. When the submit button is pressed, it will send an HTTP POST request with the data contained in the body of the request. The HTTP POST method is more secure than the HTTP GET method. However, the data could still be read by a third party listening to the HTTP request. To secure this completely, HTTPS is used to encrypt the data so that only the sender and receiver can understand the data. Once the web server receives the request, it processes it and sends back a HTTP response. If the request was successful, the response will direct the web browser to a new web page. If errors occurred, there are many ways this can be handled by the web page, as explained in a previous video. You should now be familiar with how forms are sent to web servers and the difference between GET and POST. CSS, or cascading style sheets, is a set of rules that enhance the appearance of web pages. In the early years of the internet, browsers adopted CSS because it presented an opportunity for better visual designs and more creativity. As browsers continue to develop and grow beyond traditional devices, CSS's capabilities developed in parallel. This development includes the introduction of responsive design in CSS and has further grown from there with layout options such as flexboxes, grids, and boxes. And you could argue that layouts is one of the most important components of designing a good web page because layouts help divide a page into different sections, thus making the page more presentable. So let's learn more about CSS web layouts. CSS can be used to enhance a web page by modifying fonts, colors, layout, size, and other style formatting options that make the web page more presentable. The browser window that is visible to the user on the screen is called the viewport. In essence, the idea behind any CSS web layout is to create an optimally designed web page that has a good viewport at any given point. In other words, CSS layouts are all about how the content of your web page is organized. When it comes to creating layouts using CSS, an important property is the display property. What does it do, you ask? The display property specifies the type of box that you want to use for a given HTML element. You might remember from an earlier course that the display property determines if a rendered box is inline or block. Box models allocate rectangles or boxes to HTML elements so CSS rules can be applied. For example, the relative CSS rule for a HTML element with an ID named sample would contain display property with a block value. The code changes the property of the display box to a block type. Layouts created using the block type are good, but evolving requirements led to the development of CSS web layouts such as Flexbox and Grid, which help create rules for multiple elements. They added more flexibility and dimensionality with better options for fine-tuning specific sections of a web page. The main difference between the two is that Flexbox is one-dimensional, while Grid, as the word implies, is two-dimensional. You will examine these in more detail over the course of the module, but for now, let's just do a brief overview. Flexbox is short for Flexible Box Model, and it was introduced before the Grid layout. For example, the Flexbox property with an ID named sample contains the display property with flex as its value. Flexbox adds responsiveness to CSS with float elements and positioning. One-dimensional refers to the fact that a given Flexbox container will arrange items in either a column or a row along its axis. The Flexbox container applied over an element can flex to shrink or expand, thus resulting in a flexible, responsive design. CSS Grid is similar to the Flexbox, except it creates a two-dimensional grid along both the row and column axes. For example, the grid rules for the sample ID can be added after adding the display property with the grid as its value. While the grid increases dimensionality and helps to create an advanced layout with relative ease, it can also lead to increased complications later if the element rules are not systematically defined. There is no strict rule on choosing which layout to use, but in general, flexboxes are more suitable when you want to create flexible elements in smaller spaces, while grids are more suitable to large-scale layouts. A separate explanation of each type of layout has been given in this video, but in practice you'll likely encounter the use of more than one layout in rendering a single page. The rules for these layouts in CSS are standardized, but that doesn't mean you are limited when it comes to creativity, aesthetics, or optimization when designing a web page. You will learn more about how to use these layouts during the course. Earlier, you learned about the different types of CSS selectors. Remember, CSS selectors correspond to specific elements or element groups in a HTML document. In this video, you will learn about additional commonly used CSS selectors. But before you explore them, let's briefly revise the ones you've already covered. You learned about element or type selectors. The element selector allows developers to select HTML elements based on their element type. You also get ID selectors. ID selectors use the ID attribute of a HTML element. Since the ID is unique within a web page, it allows the developer to select a specific element for styling. You were also introduced to class selectors. Class selectors allow you to select elements based on the class attribute applied to them. With class selectors, you can apply rules to all elements with the specified class name. Those are the CSS selectors you have learned about previously. Hopefully, you've experienced how useful and effective they can be. But that's not all. As the CSS codebase evolved over time, more selectors were added to improve the design and styling effect of CSS. Let's explore a few of these widely used selectors. First, let's focus on attribute selectors. The attribute selector has a few syntax variations. Attribute selectors match the attribute or value for a given element. Can you recall what attribute and value mean? A quick recap. Let's say you have a HTML image tag. img is the name of the tag, while src and alt are the names of its attributes. The actual name of the image file, first.jpg, is the value. Now let's explore an example of how attribute selectors can be used. Say you have a HTML file with 3 A tags, each with a href attribute that points to a different page on the Meta website. The first one has no class, whereas the second one has a class called Home and the third a class called About. With different variations of the attribute selectors, you can target different attributes of the HTML. For instance, you can style all elements that have a defined class by adding class inside the square brackets. In this case, it will turn the second and third link green. Alternatively, you can target all 3 elements by inserting the href attribute, a star, and a common value that is part of all the links that you want to target. In this case, it can be the text meta. Now all 3 links will be green because each link contains the word meta. Or you can target only the first element by adding the specific link as the value of the href attribute that you want to target inside the square brackets. Wherever there is an attribute on a web page, you can use some variation of an attribute selector to modify it. This makes attribute selectors a very flexible styling tool. But let's move on to 2 other widely used selectors that you need to know about: nth of type and nth child selectors. The syntax of these 2 selectors is very similar. As their names suggest, these selectors target the nth child or nth type of a specified parent element. But what does parent mean exactly? Well, say you have a few list elements in an unordered list element. The unordered list element is the parent tag in this case, and the 3 list elements are the children. Now let's specify that the second list element must have a certain styling. In this case, you can use both the nth of type and the nth child selectors to do that. Both will produce the same output, where the second list element will be colored aqua in this case. Another commonly used selector is the star selector. Just like in many other programming languages, star selectors are used for selecting all the elements of a web page. It will affect all the elements in the HTML file. It is especially helpful when you want to reset the default settings and styles that browsers use before they apply your styling to the web page. Finally, did you know that you can group selectors? If you want to apply the same styling to more than one type of element, like the heading one and paragraph elements, you can use group selectors. Instead of using element selectors where you use a rule for every element, such as heading 1 and P, you can type H1, P and then add the CSS properties. The CSS rule will then be applied to all heading 1 and paragraph elements. Group selectors can save you a lot of time. They are also called selector stacking. In this video, you reviewed the CSS selectors that you are familiar with. You also learned about additional widely used CSS selectors, their syntax, and how they can be used to target specific elements on your web pages. The selectors covered were attribute selectors, nth of type and nth child selectors, star selectors, and group selectors. Learning how to use these CSS selectors is important because it allows you to be more specific when styling your web pages. In the rest of this lesson, you will be introduced to several advanced selectors. At first, they might seem more complex than the ones covered in this video, but with a bit of practice, they will become part of your everyday web styling toolkit.
By now, you've learned how CSS styles individual HTML elements. But how does the web browser know where to place the elements on the screen? The web browser's normal way of calculating the position of HTML elements on the screen is called document flow. By default, nearly all HTML elements are organized into one of 2 categories, namely in block and inline elements. A block-level element will occupy the full horizontal width of its parent element and the vertical height of its content. Each block-level element will have a new line before and after. Therefore, multiple block-level elements will stack on top of each other like a stack of boxes. Inline elements only occupy the width and height of their content. They don't appear on a new line, hence the name inline. Therefore, multiple inline elements can form a row of elements. When coding in HTML, you need to be able to recognize and use block elements. Some examples of block-level elements include the tags div, form, and heading. You also need to be familiar with common inline elements. These include the tags anchor, image, input, label, bold, italics, emphasis, and span. Let me demonstrate the difference between block and inline now by using an example of an HTML file containing div and span elements. Okay, so I've opened Visual Studio Code here. I will now demonstrate an example where you will learn about document flow. First, I want you to notice that I have a div element containing 3 sentences of lorem ipsum. A div or divider element is used to divide content into sections. If you don't speak Latin, don't worry. Lorem ipsum is placeholder text that has been used since the 1500s. Each sentence contains a span element that you may recall are inline elements. Notice that all text is displayed in an unbroken flow of content in the browser. In the code, I have div and span elements. I am now going to change the middle sentence from a span to a div tag. Because the div tag is a block-level element, notice that the sentence has been moved to a new line and the span element after it is also on a new line. It's possible to change elements from block level to inline and vice versa. This can be done using the display CSS property. Let me add a CSS file called style.css. In my HTML file, let me give the middle sentence div element an ID. I now add a rule in the CSS file to change the element to an inline element. To create the CSS rule, I type #middle and open the curly brackets. On the next line, I type display : space inline semicolon, and on the next line, I close the curly brackets. Notice that the div has now changed to an inline element. If I want to change it back, I can just remove the property. I have deleted the rule in the code to change the element to an inline element. Another way to achieve this outcome is to set the display property to block. I have now changed the value for display to block. In another video, I'll demonstrate to you that there are other values you can set for the display property to change the layout behavior of an element. Congratulations! You have now learned about block and inline elements in HTML. It's important for developers to be comfortable working with each and to know the differences. It's vital to keep in mind that block elements start on a new line and span the entire page, and inline elements work within the flow of the surrounding content, rather than breaking onto their own line.
At this stage, you should be familiar with different layouts and grid structures, and you should be ready to start using Flexbox. Let's explore a few practical examples of how you can use it. In the next few minutes, you will explore what the 3 most common uses of Flexbox are. As mentioned earlier, Flexboxes are more suitable to use for simple layouts or designing simple elements in a page. In line with that idea, let's explore a few commonly used design elements that you see on a page. You will discover simple ways in which you can utilize Flexboxes for binding elements together or creating an easy layout. Let's explore the 3 most common uses of Flexboxes in CSS. The first application of Flexbox that you will cover that is commonly used is a search bar. You can use Flex in search bars because it ties up all the elements, such as the small search icon, the search input area, and the submit button. Next, you can create the navigation bar using Flex, which consists of several different layouts. And it makes your navigation bar highly responsive on different devices. Finally, another type of Flexbox that is commonly used is an image gallery. Flex is helpful here as it can realign itself as you change the size of the window. In the next few minutes, you will discover how to create these Flexboxes to ensure a simple layout. In the first example of a Flexbox file, I will create a search bar. I add a reference to the CSS file in the head section of the HTML page. After that, I add content inside the body section of our HTML code. I first create a container class with a div tag. Inside this container, I have 3 different elements, which are the search icon, the search box where I type my search, and finally the submit button. In the CSS code, I first write rules for the container, then for the search icon, the search box, and finally for the button. Most of the properties defined here are settings for the alignment of the selectors. There are just a few important things to take note of. The display property I use is inline flex instead of flex, which makes the flex container behave like an inline element. Another property to take note of is the overflow. The overflow property clips the overflowing content, which in this case will be the text I enter in the search query. Then I add the properties for the icon and the search box. Finally, I add the properties for the search button. Let's remove this CSS code momentarily to check how the output displays without it. Although all the elements are there, the page is standard and plain. I add the code back to the CSS file and check the output one more time. Now the search box displays the properties that I defined in my CSS file. Notice that when I change the size of the page, the search area doesn't change. Another place where Flexbox is used quite frequently is in navigation menus. In this case, I created an unordered list that consists of 4 items. Notice that in my CSS code, I use something called a star or universal selector. The universal selector applies the rules to every element in my CSS code. I use this to clear any formatting that is browser specific. Now I define the rules for the container. It's important to notice that I use the flex flow, which is a shorthand property specifying the direction of the flex container and its behavior for wrapping. Another important property is justify content, which aligns the flexible container's items along the main axis. In this case, I have set it to stretch. Since the individual elements are part of the container, I applied the rules both to the container and to the element, which are the list items, anchor tag, and so on. It's also important to notice that the page is responsive. So, as the size of the browser window gets smaller, the items stack on top of each other, and if I expand the window, it changes to a standard horizontal navigation menu. One final Flexbox example that I will demonstrate is a responsive image gallery. All the elements for the gallery is in the body of the HTML file. There is a div element with a class container that consists of 6 images that are saved inside the project folder. Now let's open the CSS file. First, I remove all browser-specific settings that may be there by using the star selector, just like I did earlier. I set the value of both the margin and the padding to 0. I then reset the basic alignment options for the images by setting the border to 0. Next, let's focus on the container. First, I set the value of display to flex. Then I add the flex wrap property, which determines whether the flex items should be forced in one line or should wrap over multiple lines. Next, I justify the content property, which aligns the flexible container items on the horizontal main axis. I set it to space dash between. Finally, I add some padding. Let's inspect the output. The output window is narrow at the moment, so the 6 images are stacked on top of each other, but when I expand the window, they spread out. One can notice the effect better in a browser, so I copy the link and paste it into my browser. When I change the size of the browser window, it is clear that the alignment of these images is responsive. These are just some of the ways in which you use Flexboxes to provide responsiveness to websites and bind different elements together on web pages. You should now be more familiar with some simple ways in which you can use Flexboxes to bind elements together to create an easy, responsive layout on your web page. Good job! CSS grid layouts are important when it comes to designing a good web page. This is because layouts are a way to provide visual cues for a user by organizing relevant content to make it easier to comprehend. So let's learn more about layouts. When someone says the word grid, you probably think of lines that cross each other to form squares or rectangles. CSS grids are 2-dimensional design layouts that are responsive and compatible with browser variations. They are an alternative to other options such as flexboxes and tables, especially when you are working with larger scale layouts. Columns are the vertical tracks and rows are the horizontal tracks in your viewport. Grids divide the page into rows and columns, and the space between these tracks are called gutters or gaps. And a cell is the space in a grid container where a row and column intersect. There are several different configurations you can add to define and modify grids. Let's examine an example that uses a HTML document to demonstrate how to iteratively make changes to a grid. First, let's create a HTML document called index.html. Right now, the contents displayed in the viewport are just a vertical series of letters from A to E without any styling. Let's start adding content to the CSS file. The first thing to do is set the values for the properties of the different box classes inside the container object to make the layout look more presentable. The letters now have a better visual design, but their arrangement on screen is unchanged. The result is that each letter occupies more screen space than is necessary for its size. What's displayed in the viewport may appear to be a grid, but it's not actually one. It's just the default settings of CSS for a layout. Once you convert this into the grid layout, you'll be able to recognize the flexibility it can add. So let's convert it into a grid layout. Set the properties of the container class by first assigning a grid value to the display property. The display property is also used to set display types for other designs such as flex, block, inline, and so on, and it's usually a part of container elements inside our code. The updated container now has the display property value set to grid and the property values configured for 3 columns and 2 rows. That's 2 changes from the previous configuration. Let's examine them. The grid template columns property has been added into the CSS code to set the size of each of the 3 columns using pixel values. The use of FR, which is an abbreviation for fraction, has been introduced. Fraction effectively divides the grid, and the page now displays 5 separate grid cells around the letters, which are arranged in 3 columns and 2 rows. Where applied, the grid tracks are divided proportionately to the ratio of all the fraction values present. As there are 2 rows, the defined values are sized in the ratio of 2 to 1. Fraction adds flexibility to the grid without needing to deal with actual pixel sizes. It must be noted, though, that fraction and pixel sizes can be used interchangeably with both rows and columns. Now to add a couple of properties such as grid gap or gutter and background color to define the grid. The updated view displays a red box representing the grid because that's what the background color's RGB value was set to. The grid stretches by default the entire width of the page. And the size of the grid track or gutter has been adjusted to 10 pixels, which leaves more space between the grid cells. You can also opt to use the auto properties such as grid auto rows and grid auto columns, collectively called the implicit grid. Let's replace the grid template rows property in the code with grid auto rows. All the rows are now auto resized to 100 pixels. Now let's examine some of the functions that can make configuring the layout easier. First, the repeat function passes the number of repeats required for a given number of rows and columns. The result of the code adjustment is an unchanged web page from the last instance because the repeat function didn't change anything, it just reduced the amount of code you needed to write. Therefore, the repeat function helps reduce redundancy and provides ease of code modification. Next, the min-max function sets the minimum and maximum values expected for the sizes of rows and columns. Let's set the value for the grid auto rows to 150 pixels. The output is modified so that the minimum size of each row is 150 pixels. One more important concept is grid frameworks. There are a number of commonly used grid frameworks in layouts. 2 such grid design layouts are known as the 12 and 16 column grids. They divide the page into 12 and 16 tracks respectively along the vertical columns. The properties can be modified accordingly to target a specific track. CSS grid layouts are so important when it comes to good web page design, and this video has demonstrated that layouts provide visual cues for the user by organizing content in a way that makes it easier to understand. Who knows, soon you'll be building your own web pages and you'll be able to test out some of the techniques shown in this video. And don't forget the repeat and min-max functions. They'll save you time and effort. Pseudo-class selectors give developers great control over what they select and style. By knowing how to use these selectors, you will not only improve the interactivity of your web pages, but you will also be able to add advanced styling without too much effort. These selectors are also often referred to as just pseudo-classes. Previously, you were briefly introduced to the pseudo-class invalid. Remember, pseudo-classes are state-based selectors, which means that they allow you to select elements based on their state, for example, the hover state. You use pseudo-class selectors to improve the interactivity of web pages by styling elements in response to user input. In this video, you will explore practical examples of how to do this. There are many types of pseudo-classes. Other than the hover state, examples include selecting an element when it is active or in focus, or when a link has already been visited. Pseudo classes are also very effective to target specific elements such as, let's say, the fifth item in a list, bold items, empty elements, and so on. Let's review the general syntax that you use for various pseudo classes. You add the selector, a colon, the pseudo class, and then the properties. While there isn't a broadly accepted classification for pseudo classes, you can group them in terms of general similarities and their purpose. Let's explore a few of these general classifications. The first group you need to know about is user action states, which include the hover pseudo class, which changes the style of an element when a cursor hovers over it. The active pseudo class, which styles an element only while a user actively presses and holds the mouse button. And the focus pseudo class, which focuses styling on the element that you use it for. These pseudo classes have an effect while a user is actively engaging with a HTML element. Let's explore an example of how the hover and active pseudo classes can be used. Say you have a HTML file with an A tag inside a paragraph and a button element inside a div element. The paragraph element has a class defined as myPage, and the button class is defined as myButton. Now let's explore the CSS. First, it contains basic styling for the myPage and myButton class elements. Then, to make the link change its appearance when a user hovers over it, you use the hover pseudo class to target a tag. To change the myButton class, you use the active pseudo class. The active pseudo class changes the properties of an element when the state of that element is active. In this case, the styling properties will be applied only when a user presses and holds the mouse button. In this example, the pseudo class selectors target HTML elements, but you can also use them to target HTML class attributes. Next, let's focus on form states. Previously, when discussing form validation, you were introduced to the invalid pseudo class selector. But there are more pseudo classes that are specifically used for HTML forms. They usually come in pairs and target the different states that elements can have. Form state pseudo classes include disabled and enabled, generally used for buttons, checked and indeterminate, that are used for checkboxes, and valid and invalid, used in case of fields like emails and phone numbers. Another pseudo class type that you should know about is specific position-based states. They allow you to target specific items, for instance, a specific list item among the list elements. Some examples of this type include first of type, last of type, nth of type, and nth last of type. Let's explore an example of first of type. Say you have two list items in a HTML page, Adrian and Mario. With the first of type pseudo class, you can style the first item of its type while the remaining items will not be affected. In this video, you explored a few examples of how you can use pseudo classes to improve the interactivity of your web pages. There are plenty of other pseudo classes, and some of them are more popular than others. You're encouraged to follow your own style and explore the creative possibilities that pseudo classes offer.
In the last few hours, or maybe even in the last few minutes, you've probably interacted with web pages to do things like watch videos, look for locations on maps, or interact with your social media feeds. In fact, you're doing it right now with this course. But what makes this interactivity possible? The programming language JavaScript. Let's find out a bit more about the benefits of JavaScript and its importance to developers. JavaScript is a language that builds interactivity into web pages. It is literally the language of the web. Almost every website runs JavaScript in some form or another. The reason for this is the fact that since its very inception in 1995, JavaScript has been the main way to interact with web pages on the client side, the front-end side of websites and web applications. Using JavaScript, updates are displayed in real time on our devices. Some common examples include interactive maps and client-side form validation. Over the years, there have been some alternatives to JavaScript, such as VBScript and more recently, TypeScript. But even TypeScript compiles down to JavaScript, so browsers can understand it. Since JavaScript is one of the most widely available and frequently used methods for interacting with the browser on the client side, the language became immensely popular. In fact, developer surveys often show that JavaScript remains one of the most popular programming languages today. So, What is it that makes JavaScript so integral to modern browsers? JavaScript is currently the only computer language that allows us to directly interact with our web pages dynamically on the client. It's baked into the browser. Its enduring popularity is down to the rules of backwards compatibility, which state that all websites that were built in the past still need to work today. So, removing JavaScript from the browser would effectively render millions of websites completely useless. This means that JavaScript is in the unique position of being one of several central pillars of web development. You've just discovered the importance of JavaScript to web development. JavaScript's unique ecosystem is one of the main reasons for its popularity. Simply put, browsers speak JavaScript. But there are a few other important reasons why we should embrace JavaScript. One of the main reasons that developers use JavaScript is because of how easy it is to use. There are many programming languages where a newcomer needs to do a substantial amount of prep work to even get set up and ready to learn. However, with JavaScript, it's as simple as opening the browser's developer tools and navigating to the console tab, because every browser has a JavaScript engine built in, and you can interact with it using the console. There are still a few small steps required to get started with JavaScript. These include installing a code editor and possibly setting up some other things such as Node.js and npm. But initially, as a beginner, it's enough to just open the developer tools on your web browser. Another reason to learn and use JavaScript is because, as we saw earlier, it's everywhere. JavaScript is used in almost every website there is. It's used on the client side of sites as plain JavaScript, also known as vanilla JavaScript. It fuels a myriad of JavaScript frameworks such as React, Vue, and D3. And it's also used on the server as Node.js and more recently, Dino. Another reason why people often choose JavaScript is that it's considered one of the more accessible programming languages. It also has a wide development community to offer help and guidance. This is especially true when it's compared to other languages. There are many languages that, for a variety of reasons, would be very challenging to begin programming with. But because it's so approachable, JavaScript can be a great way for new developers to jump into programming. So, besides being a useful skill on its own, JavaScript can also be a stepping stone to other languages and technologies. Finally, one more reason to learn JavaScript is because JavaScript skills are in demand. Countless job postings appear for JavaScript developers every day, and these will keep coming for the foreseeable future. So, next time you ask why choose JavaScript, remember that it's the foundational technology of everything you do online, with a huge variety of uses. Plus, it's easy to get started with, and once you're up and running, there's lots of job offers and projects open to you. Best of luck with your JavaScript journey. JavaScript is used in many scenarios, for example, in the browser to help add various kinds of behaviors and interactivity, like adding an item to a shopping cart when you click a button. On the server, it can be used to power up websites, communicate with databases, and provide a native feel to web apps. It's used to build mobile apps using technologies like React Native, and it's used to program devices known as the Internet of Things. In a nutshell, JavaScript is everywhere. This means that there are many different use cases for JavaScript, and with these different use cases come different implementations, each geared towards solving a particular problem. For example, in the early 2000s, different companies built internet browsers and were referred to as browser vendors. However, with different browsers came different behaviors with various discrepancies between other browsers. This resulted in developers sometimes having to write separate JavaScript code for different browsers. This wasn't the best use of developer time and could lead to a frustrating experience for end users. Out of this frustration, several projects appeared, trying to solve this compatibility problem. One such project managed to solve these issues, and it was a library named jQuery. Using this library, all a developer needed was to import jQuery and write code using its features. This code would then work across all browsers. At the time, it was like magic, as it was such a great solution to the problem of incompatibility. And jQuery became the most popular JavaScript library for well over a decade. However, as the web and the way we code kept evolving, new problems appeared, and soon enough, new solutions to those problems needed to be built. One such solution was React, which came out in 2011, and it had a considerable effect on the way we think about websites and how we build them. React solved many of the issues associated with creating, updating, and maintaining complex websites. Soon, many other technologies appeared, attempting to do the same. These include Knockout, Backbone, Angular, Ember, Vue, Alpine, and others. With millions of websites containing JavaScript code from different versions and libraries, there is a lot of old code. This is known as legacy code. While you probably won't use jQuery to build a modern website today, you might still come across it in a project that is still actively running. But don't worry. Sometimes beginners think they have to learn or even master all the different technologies associated with JavaScript. However, that's not really necessary. To be a well-rounded developer, you need to learn and master the basics of plain JavaScript without the frameworks. Once you have this foundation, the pathway will become easier for you to learn a framework built on top of JavaScript, such as React. When you start programming in JavaScript, it helps to think of an empty JavaScript program as the first level of a sandbox game. The world is still empty, but there's some underlying structure to it to build on. That structure needs to be there so that you can write custom JavaScript code in the first place. However, besides the underlying structure, a new JavaScript program is kind of like a blank slate for you to build on. It's up to you, the programmer using JavaScript, to say, let's build this world. And an important part of this process is knowing how to use variables. In this video, you will learn how to identify what a variable is and why you need it, distinguish between variable declaration and variable assignment, and describe how to get a variable's value and reassign it. Let me demonstrate this now, using some code to assign a value to a variable and output it to the console. Right now, I have the Developer Tools panel open in my web browser. You can access this by pressing F12 on Windows and Linux or Command-Option-I on Mac. Then I select the Console tab. This works with any browser, and for this example, I'm using Google Chrome. Now I want to give JavaScript some idea of what I want to build, and I start by adding a person's name. I do this by typing John in double quotation marks. JavaScript receives this person's name and accepts it. There are no errors. This means I've given it some valid data, something that JavaScript can work with. Now let's say that I want JavaScript to say, "Hello, John." In other words, I want it to use the name that I gave JavaScript and I want it to greet the person. But how do I do it? If I type "Hello, John," I'm just typing the whole thing myself. I really want JavaScript to use the name I provided so I don't have to keep retyping it. And this is where variables come in. By using a variable, I can save the name John so that I can reuse it in the future. To save this name in a variable, I'll start with the keyword var and use it to signal to JavaScript that I'm giving it a value that I want it to reuse. To declare a variable, I type the keyword var. Now, I need to declare a fact about this world that I'm building. So I type person, semicolon, and press enter. Great. I've just declared my variable, person. I've given JavaScript one fact about the world that I'm building. The fact that there is a value that I'd like to reuse and that this value is accessible using the word person. Thus, I have completed the variable declaration. However, I still haven't given a name to the person variable. In programming jargon, I'd say that the person variable hasn't been assigned a value yet. The person variable is still undefined. In other words, for the person variable to hold the value of John, I need to assign the value of John to the person variable. To do this, I'll use the assignment operator. the equal sign. Operators perform certain operations, and the assignment operator's purpose is to take the value that is on its right and put it into what is on its left. So, to assign the name John to the variable person, I type var, person equals John in between quotes. I've taken the value John and assigned it to the person variable using the assignment operator. To confirm that this is really the case, let me inspect the contents of the person variable by typing person semicolon. It returns John as the result. Now that I have this value in a variable, I no longer have to type John every time I want to use it. I can have JavaScript output the text, "Hello John," to the console by using the built-in console.log method. This is a common approach to outputting values in JavaScript. Notice that the browser is intelligently trying to guess what programming statement I want as I type. Don't worry about this now. I just want you to concentrate on variables and the console.log method. The console.log method can accept one or more values, separated by commas. So I type console.log, open parenthesis. Then I type hello in quotes, comma, person for the variable, and then close parenthesis. Notice that hello John is now logged to the console. This is an example of combining static text with a dynamic variable where the value can change. But why stop here? Why not save the greeting in a variable too? Let's create another variable and call it greeting, and assign this new variable the value hello in quotation marks. Now, when I use the console.log method with both variables, greeting and person, the words or the values of these variables, hello John, are logged to the console. Finally, let me show you why variables are so useful. Now that I have the person and the greeting variables, I can reassign them, replacing their stored values. For example, I can change the value of the variable from hello to hi by typing greeting equals hi in quotation marks. Similarly, I can change the value of the variable person from John to James by doing the same thing. I type person for the variable, then equals, and finally James in quotation marks. Now the value of the variable greeting is hi, and the value of the variable person is James. Notice that now I haven't used the var keyword when I reassigned the values to the variables that I created earlier. That's because JavaScript already knows that these variables exist in the world that I'm building. But the variables don't have to be static and unchangeable. That would be a pretty boring world, right? Now, I run the exact same piece of code as before by typing console.log and the name of the variables. Notice that I'll get a completely different result logged to the console, hi James. This is very important because it allows me to use the same code and get different results. This is the power of variables. If you want to find out more, there is an additional reading at the end of this lesson. Congratulations! You now know how to create a variable in JavaScript. Variables allow us to make the exact same code produce different results, making our programs versatile. And that's it for this video on variables. Now that you've had some insight into how JavaScript's world building works, I hope you are excited to learn about more than just variables. Imagine for a moment that you are faced with the task of moving all your belongings to a new place. What steps would you take to make the process more efficient? Well, you'd probably start by sorting items and packing them into boxes, and then labeling those boxes so that you have an idea of what each one contains. After moving them, you put each box in the room it belongs, to make unpacking quicker and easier. You can also think of programming in a similar way to packing and moving boxes. You have many different data types at your disposal, but coding efficiently starts with knowing when and where to use them. In this video, you'll learn to identify the primitive data types in JavaScript. You will learn about their specific use cases and when to use each data type. There are 7 primitive data types in JavaScript. These are string, number, boolean, null, undefined, big int, and symbol. Let's begin by learning about the first 2, which are strings and numbers. Let's say that you are building an e-commerce app for selling guitars. When a user views the page for the most popular model, you want them to see the name of the guitar, the description, the best guitar around, and the price of $375. Seems simple enough, right? But how can you ensure that the information displayed on screen is stored effectively so that the app can use it? You would do this by using the most appropriate data types. But what does data mean exactly? Well, each piece of information in your app has a different value, and all values are collectively referred to as data. But the values differ and therefore need to be stored differently. For example, you store the name and description as text values, and the price as a numerical value. In JavaScript, text values are known as the string data type, while numerical values are referred to as the number data type. From a programming perspective, making a distinction between numbers and text is important because they adhere to different rules. For example, to build a number, you simply type in the numerical values, but to build a string in JavaScript, the characters must be enclosed in either single or double quotes. There is also a difference in the number of combinations that the number and string data types can store. The number data type has a very wide range in JS, enough for most common use cases. However, it is limited up to a point, determined by JavaScript's calculation capabilities. The string data type practically has an unlimited number of combinations of characters. There is almost an infinite number of ways we can combine different characters into strings. Okay, so back to our app example. The data must be stored using different types. The price will be stored as a number, while the name and description will be stored as strings, with each one wrapped in double quotes. You now know that the string data type is great for storing values such as titles and descriptions, while the number data type is better suited for prices or any value that you would like to calculate. However, there are additional data types in JavaScript to help you tackle different tasks. Next, let's explore each of the remaining data types and their specific use cases, to better understand how you might make good use of them. Let's think of each one as a box, like I mentioned earlier. The Boolean data type has only 2 values, true and false. This means that it is useful for making decisions. Sometimes it's necessary to know when a variable does not contain a value, and JavaScript has 2 data types to express just that. First, there is the null data type, which only has the value null and represents the absence of value. You also have the undefined data type, which can only hold the value undefined and usually refers to a variable that has not yet been assigned a value. The capabilities of JavaScript have evolved over time, and version ES6 introduced 2 new primitive data types to help with more complex tasks. One is the big int data type, which is like an extra large box that can accommodate a much greater range of numbers than the number data type. Finally, there is the symbol data type, which can be used as a unique identifier. Think of it as having multiple boxes with the same label and using different serial numbers to avoid mixing them up. In this video, you've learned about the various data types available in JavaScript. Remember that every data type has a specific use case, and knowing when to apply each one will make you a better coder. See you next time. Where do you think the name operators come from? Does it have something to do with an operation of some sort? Well, the answer is yes. Operators are used to perform operations on variables and values. An operator is used to manipulate individual data items and return a result. For example, you may already be familiar with the assignment operator to assign a value to a variable. You use assignment operators for simple and complex calculations. They provide us with similar options to those on a calculator. In this video, you will learn about assignment and logical operators and how to use them in JavaScript. First, let's start with the assignment operators which you can use to perform simple arithmetic. For example, to add two numbers, you can use the addition operator, which is represented by the plus symbol. If you want to subtract values, use the minus operator, which is represented by the hyphen symbol. If you want to perform division, for example, 35 divided by 5, use the division operator, which is represented by the /. Finally, to multiply numbers, use the multiplication operator, which is represented by the star symbol. In addition to assignment operators, you can also use comparison operators, which compares and returns a logical value based on whether the comparison is true. For example, you can compare numbers to check if they are greater than, less than, equal or not equal to each other. You will learn more about the various assignment and comparison operators later in this course, but for now, let me tell you about logical operators. Logical operators are used in JavaScript to determine if something is true or false. For example, the logical operator named AND, which you can use to check the two or more conditions are true. Imagine you had a variable named A, and you wanted to check that its value is greater than 5 and less than 10. For this to be satisfied, both statements must be true. Alternatively, there is the operator named OR, which checks for at least one of the statements to be true. For example, A is greater than 5 or A is greater than 10. Finally, you can use the logical operator NOT, which returns a false value if the result is true. Operators are used to control the flow of a program that meets certain criteria. Now let me demonstrate how to use JavaScript math and logical operators. Okay, so I've opened VS Code here, and now let me demonstrate how you can use arithmetic and comparison operators in JavaScript. Recall that comments are used to specify which lines JavaScript should ignore. As you learned earlier, you can put almost anything inside comments. Notice I have two multi-line comments. The first one lists some arithmetic operators, and the second one lists some comparison operators. I also have several single-line comments. You already learned that JavaScript completely ignores comments, and here's the proof. I click on the Run Code icon. Notice that the output in the right panel will not show any values other than the expected additional info on the code that was run. Let me clear that for now and show you how to work with some arithmetic and comparison operators. I'm going to uncomment all single-line comments from lines 14 to 21, so that you can focus on each of these console logs separately. This will then allow me to demonstrate how each of these operators behaves. So let me delete the two // on line 14 and rerun this file. Notice I get the value of 4 outputted to the console, resulting from adding the values 2 plus 2. Okay, let me clear the console, comment line 14 and uncomment line 15. This is an example of adding multiple numbers using the plus operator. Notice when I run this, I get the output of 15. Let's do another one using the subtraction operator to subtract 18 from 20. If I run this, I get the expected output of 2. Next is multiplication, which is represented by the asterisk symbol. Here I will console.log the values of 2 times 3 to get the value of 6. On line 18, I use the / symbol for the division of 8 by 1. And notice when I run this, a value of 8 is outputted. Success! And that's it for performing simple arithmetic in JavaScript. Okay, let me clear my screen again. Now I want to demonstrate how to work with comparison operators. Notice on line 19, I use the greater than symbol to check if 3 is greater than 2. Run it, and indeed it is. I get an output of true. On line 20, I use the greater than symbol to check if 2 is greater than 3. And since it's not, I receive an output of false. These words true and false are special kinds of values used in JavaScript. Don't worry too much about them now, as you will learn more about this later. For now, I just want you to focus on the final line of code. This checks if one value is equal to another value. It's important to remember that you need to use the equal symbol twice for this comparison operator to be valid. This is because the single equal symbol is used for the assignment operator, like when you assign a value to a variable. Okay, so I would expect the value of 10 to be equal to 10, so let's run it to find out. And it is. Notice a value of true is outputted to the console. Congratulations! You have now learned how to work with operators in JavaScript. This is a must-have skill in your development toolkit, as they are used in many areas of programming. Great work!
In JavaScript, like in other programming languages, there are different data types. The number data type is the foundational part of JavaScript as a programming language because it represents both integer and decimal point numbers. Without it, you wouldn't be able to code. And with such a crucial data type, we better get started right away. So let me demonstrate the number data type. I type the value 123 into the console and press enter. Notice that the output is 123. Next, on a new line, I type a decimal value 123.456, which is also a number data type. I press the enter key again and get the decimal value 123.456. In JavaScript, we can use numbers to perform math operations. For example, I can code 2 plus 2 and get the value of 4 returned. Just like in regular mathematics, we use the plus symbol for addition. Similarly, use the minus symbol to perform subtraction. For example, 4 minus 2 returns the value of 2. For multiplication, use the asterisk or star key. So, 4 times 4 will return 16. For division, use the / key. 16 divided by 4 returns the value of 4. You can use a double star sign to perform exponential calculations for slightly more complex arithmetic. For example, 10 to the power of 2, 10 times 10, will return 100. A final example is the remainder or the modulus operator. This checks how many times you can fit one number into the other and then returns the remainder. So if I type 9 modulus 8, the value of 1 is returned. Or 16 modulus 8 returns a 0. This is because the number 8 divides into the number 16 evenly. There is no remainder as represented here by the 0. Besides basic mathematical operations, you can also use parentheses to group more complex calculations. For example, 2 times 4 plus 8 can return a different answer depending on the order used for calculation. For example, multiplying 2 times 4 and then adding the value of 8 returns 16. But 2 times the value of 4 plus 8 returns 24. By using parentheses, I can control the order of calculations. Without parentheses, JavaScript will follow the standard mathematical sequence of calculation. In this case, the multiplication would take precedence and be done first. So the 2 times 4 happens first, and then the 8 is added, returning a value of 16. Remember, I can override that using parentheses and get a different result. That's an example of using parentheses in JavaScript with numbers and mathematical operators. Some of the most common JavaScript mathematical operators are plus, minus, times, division, and modulus. If you would like to learn more about mathematical operators, there is an additional reading at the end of this lesson. Since you're new to JavaScript, you might not be familiar with strings. Strings are used to represent and work with a sequence of characters while programming in JavaScript. Let me explain how they work. To demonstrate the concept of strings, I have the developer tools open in my browser and the console tab is selected. So what is a string? A string in JavaScript is a collection of characters enclosed by single quotes, double quotes. Such a collection of characters is known as a string data type. Strings are one of the most common types of data you'll be working with. To code a string, I type in a pair of single quotation marks. This piece of code with just an opening and closing single quote is referred to as an empty string. To build an empty string, I can also use double quotation marks.
While empty strings have their place in JavaScript, they're not very versatile. But strings don't have to be empty. So let me build a non-empty string with some letters and an exclamation mark. I do this by typing the words, "hello there," and an exclamation mark within a pair of single quotation marks. Besides letters and punctuation symbols, we can add almost any other character into a string, including numbers. For example, I can type "hello there" and follow it up with several symbols and numbers. This is still a valid string. There's one thing that strings can't do, and that is break onto the next line. When I type a single quotation mark, the word hello, and then press enter before typing the second quotation mark, it results in an error which stops the code from running. The same happens if I use double quotation marks. When you use single or double quotes to surround string values, these characters are referred to as delimiters. This is because I use them to delimit a given string value from the rest of my code. There are some unusual situations that can trip you up when you first start using strings in JavaScript. For example, let's say that I want to create a new string. I do this by typing a single quotation mark, followed by the phrase, "It is a lovely day," and I close the string with a second single quotation mark. Now I want to use the contraction of "it is" by using an apostrophe, but I get an error code. This is because JavaScript reads the word "it," that is, the first two letters, as forming a string, and then it doesn't understand the rest of the code because of the apostrophe. To fix this issue, I need to nest single quotes inside double quotes. I do this by replacing the original single quotation marks on either side of the phrase with double quotation marks. And now you'll notice there are no more errors. You can mix single and double quotes too, but it's better to stick with one or the other because it can be confusing and lacks consistency. And there you have it. You have learned what a string data type is and what an empty string is. You can also explain what the string data type is in JavaScript. I encourage you to try and make some more strings while practicing coding. The Boolean data type is used to check if a statement is true or false, which makes it a foundational part of knowing how to use JavaScript. It has many uses, but in this video, I will focus on how to get the result of a comparison to determine if two values are the same or not. What is a Boolean data type? To understand the answer to this question, let's think about a real-life scenario of comparing numbers, such as, for example, checking if number 1 is smaller than number 2. In JavaScript, I do it like this: 1 less than sign 2. When I press the Enter key, JavaScript says that this is a true claim. Let's do some other comparisons. Let's check if 1 is greater than 2. 1 greater than sign 2. This code returns the value of false of the Boolean data type. No matter how I compare numbers, the result of the comparison will always be either true or false. There are no maybes here. That's why the Boolean data type has only two possible values, true and false. Besides the less than and the greater than operator, I can also use some other operators to compare numbers. It might help to think of these various comparison operators as tests. Let's say I want to test if the comparison of two numbers is correct or incorrect. Now I will run a few tests with some additional operators, starting with checking for equality. 1 equals 2. I'm claiming that 1 is equal to 2, and JavaScript returns false. No, 1 is not equal to 2. My claim is false. When first introduced to the syntax, with two consecutive equal signs, it is not uncommon for people to be slightly confused. Why the double equal sign? After all, you know that in mathematics you only need a single equal sign to signal equality. But in JavaScript, I use a single equal sign as the assignment operator to assign a value from the right side of the assignment operator to the variable on the left side of the assignment operator. For example, I can type var score equals 100 to declare a variable called score and assign it to the value 100. In other words, I can now confirm that the value of score is 100 by typing out score in the console. Indeed, 100 it is. In contrast, in JavaScript, the equality operator has two equal signs, and it checks only for value. Additionally, there's also the strict equality operator that has three equal signs, and it checks for both the value and type. For example, if I use the equality operator, let me type 100 double equal sign, double quotation, number 100, and close double quotation. The console will return the Boolean value of true. By using the double equal signs, I compare only the value and not the type. JavaScript checks only if 100 is equal to 100, regardless of the data type. It ignores the fact that the 100 on the left of the equality operator, without the double quotes, is a number, and that the 100 on the right of the equality operator, with the double quotes, is a string. The strict equality operator is more unforgiving. It checks for both the equality of value and the equality of type. Therefore, comparing the number 100 without quotes with the string 100 with double quotes will return a Boolean value of false. Why is this false? It is false because although the value is the same, the type is not. The number 100 does not have the same type as the string 100. There's also an operator that's the opposite of the equality operator, the inequality operator. It's a combination of an exclamation mark and an equal sign. Let's test it. I type number 1, exclamation mark, the equal sign, and number 1 again. It returns the Boolean value of false because it is false to say that 1 is not equal to 1. Additionally, just like there's the strict equality operator, there's also its opposite in the form of the strict inequality operator. This operator is an exclamation mark with two equal signs. Let's type number 1 as a number, exclamation mark, the equal sign twice, and then number 1 inside double quotes, that is, as a string. This returns a Boolean value of true because the number 1 is not the same as a string 1 by both the value and the type. So it's true that these two values are not the same. There are other kinds of operators in JavaScript, and there are some additional concepts like operator precedence and operator associativity, but we'll skip these for now. With the examples covered in this video, you should have a basic grasp of how the Boolean data type works and what it's useful for. You will encounter Boolean values again because there are other important ways in which you can use them in your code besides comparing numbers and strings. One of the most powerful features of JavaScript is DOM manipulation. For example, you can click on a button and change the color of some text or even display a pop-up message. Essentially, you're dynamically updating the HTML content in real time. To do this, you must be able to locate the objects in your HTML document that you want to manipulate. In this video, I'll guide you through how to use selectors in JavaScript to quickly find specific objects in a document. JavaScript selectors work with the document object, which you can access by typing the keyword document. This returns the web page stored in the browser's memory, known as the document object model, or DOM. Alternatively, I can run a console log on the document keyword to get the same result. Let's start locating specific elements inside the document object using the query selector method. For example, I know this page contains two HTML paragraph elements. To access the first one, I type document.querySelector, then in single quotes inside of the parentheses, I type the letter P. When I press enter to run the command, it returns the first P element. I can then expand this to view the paragraph text contained within. This method can be used with other HTML elements such as the anchor tag. If I run the same command with the letter A, I get back the first anchor element on the page. There is a very similarly named JavaScript selector that allows me to get all the matches from a web page. It's the querySelectorAll method. To demonstrate this, I type document.querySelectorAll. Inside the parentheses, I pass the P letter as a string, and indeed I get back a result that shows that there are two paragraph tags on this page. Another useful JavaScript selector is getElementById, which can find objects in the DOM that match a specified HTML ID attribute. For example, let's say we want to find something on this page with the ID of heading. I type document.getElementById and then the string heading in parentheses. I press enter and notice that an h1 element is returned assigned with the HTML ID attribute value of heading. Next, let's use a similar method that returns an element based on a specified class name rather than ID. We can do this by calling document.getElementsByClassName. I type document.getElementsByClassName and then the string txt in parentheses. Again, I press enter and notice that two results are returned, the two paragraph tags containing the class name of txt. If you are a beginner on your journey with JavaScript, it is important to note that the word element is singular for ID and plural for class name. Additionally, suppose the element you are looking for cannot be found. In that case, you will be returned null for IDs and empty collection represented by square brackets for class names. In this video, you learned how to use JavaScript selectors to speed up the process of finding specific objects in a document.
Well done! You've come really far with all the courses you've completed, but sometimes it can be difficult to remember everything. In this course, you'll be returning to some key concepts of Django. So let's recap what you've learned in the Django course to make sure that you're prepared for the rest of this course. First, you learned how Django is used in the real world. For example, the developers can create a back-end framework with Django that can connect to a front-end framework. And you learned about projects and applications, admin and structures, as well as what are web frameworks. Django encourages dry principles, or don't repeat yourself. In other words, write it once but use it many times. You learned about Django admin and manage.py commands as options for command line utility to perform administration tasks, and you learned how they are used in the creation of projects and apps. Furthermore, you now know that frameworks are designed to support you in building web applications because they provide you with a clean, ordered structure. Also, recall the benefits of using the Django framework, which includes speed, feature-rich classes, security, and scalability. You also learned how Django implements the model, view, and template, or MVT architecture, and that splitting the data, logic, and display into M, V, and T rapidly creates large-scale, data-driven web applications. You then progressed to learn about the model part of the MVT framework. You learned about the concept of migrations and how to apply them using a best practice approach. You also explored how to use the query set API to interact with the database. After that, you learned how to create a form and use the form API to bind data to objects and build model forms as well as HTML forms. Then, you learned how to use the Django admin panel to add and control the permissions of users and groups. And you explored how to set up an external MySQL database for your Django app. Next, you moved on to learn about the view part of the MVT framework. You learned how to create views and view logic that can process basic HTTP requests. You now know that the view handles web requests and returns web responses. And you learned how to create a view function and map it to a URL with a process called routing so that you can make the request response work. In addition, you should be able to perform other programming logic inside of view functions, such as processing and retrieving data from a database, transforming data, and rendering templates. You also explored the URL configuration file urls.py and learned why it exists. You know that the urls.py file is already present at the project level, and configuration can also be added at the app level. You learned about the HTTP request object and should be able to demonstrate how it can be used to map to URLs, map to common CRUD operations, and get information by calling the client. Next, you unpacked URL namespacing and views, which is how URLs can be mapped to a name and its subsequent view. You also practice URL parameters and query parameters. Then you learned about the different operations for using parameters in a web application, and you should be able to demonstrate how it relates to get, put, post, and delete operations. You also learned about regular expressions in URLs. Following this, you explored how to handle errors such as dealing with HTTP status responses and dealing with error responses from the server. You also explored how developers can simplify their views by using object-oriented techniques, such as the concept of inheritance to create views from inherited classes by using class-based views that can be reused across a project. You were introduced to the Django template language, or DTL for short, which consists of constructs such as variables, tags, filters, and comments. While working with templates, you also explored variable interpolation, and you should now be able to create dynamic templates in Django and map model objects to the template. Next, you explored template inheritance, where you learned how to split out content into individual components and reuse the segments. You learned that template inheritance uses two main tags, the include and the extends tag, which allows you to replace blocks or content from a parent template. Finally, you learned about debugging and testing. You learned that debugging is about removing an application's errors and bugs, and testing considers metrics for quality, reliability, and performance. And you now know that Django has a distinct debugger that appears in the form of a yellow page error. Recall the debugger equals true flag. You also know that every language and framework have many testing options that work well in Django. A popular method is unit testing, which you can use to isolate a function, class, or method and only test that piece of code. Finally, in Django, the unit test module uses a class-based approach where you add the tests inside a class that inherits a class called test case from the Django test package. You really worked hard in the Django course and covered a lot of ground. If there's anything in the recap that you feel unsure about, please review the relevant material from the Django course so that you feel confident and ready for the activities that come later when you use your Django coding skills. Databases are a central component of any web application. The ability to provide persistent data is the key for applications to perform, create, read, update, and delete operations. While building a full-stack application, the databases can either be relational or non-relational. However, relational databases such as PostgreSQL and MySQL are more commonly used than non-relational databases such as MongoDB and Neo4j, as they provide something called a referential identity. In other words, they ensure consistency and accuracy of data with the help of keys present for records in a table and constraints that define the rules for them. In this video, you will briefly review what you know about databases, and specifically MySQL. Django supports the use of many databases with minimal configuration. These include PostgreSQL, MariaDB, MySQL, Oracle, and SQLite. Among these, PostgreSQL and MySQL are the most commonly used. Django has features to support each database that make it easy to connect and work with. It provides a generic way to access the different types of databases, and a connection to a database is established by knowing the type of database. When creating a Django project, the default configuration uses a SQLite database that requires no additional installation. It is automatically set inside the settings.py file. This means that you can directly start working with the database immediately. SQLite is known as a user-friendly zero-configuration database, and there are many advantages to using it. You don't need to install anything to support the database, as it doesn't run as a server process. This means the database does not need to be started or stopped, and it doesn't require additional configuration files. As a result, this type of database is suitable for small projects or rapid prototyping. But there may be occasions where a more scalable, robust database is needed. For example, when moving from a development to a production environment, the SQLite database has a lot of limitations. It is serverless and doesn't have a user management system. MySQL, on the other hand, can be an alternative to SQLite. MySQL has advantages such as being an open-source database. It also has a lot of other advantages over SQLite, such as scalability and authentication. To connect to a MySQL database, you need to provide the address where the database is running, the port number, and the database name you wish to connect to. There are a few steps that should be followed for using MySQL with Django. These include setting up MySQL on a local machine, installing the MySQL DB API driver, updating MySQL settings inside Django, and setting up database tables. Let's briefly explore these steps. To install the MySQL server, download the installer appropriate for your operating system. The download link can be found in the additional resources at the end of this lesson. Start the MySQL command line client with the following command: MySQL-u root -p. -u is the flag for the username root, and -p is the flag for password. You will then be prompted to enter the password set at the time of installation. In the command terminal, you will get the MySQL prompt. You can now enter any SQL statement in it. Start by creating a database with the following command: create database my_database. Then enter the next command, show databases, which will show the list of currently available databases. Next, you also need a database driver, which is responsible for mapping all the models and translating Python queries into SQL instructions via the model. There are a number of Python drivers available for MySQL. Django recommends that the MySQL API driver package MySQL client is used. To use MySQL, the driver or connector MySQL client needs to be installed. When you connect to a database, the connection opens on each request, and it's kept open for a specified amount of time. The connection is controlled by the conmaxAge parameter and represents a certain time before the connection is automatically closed. To establish a connection with a Django project, you must configure parameters under the Databases option of the settings.py file. By default, the configuration is for SQLite. You can also use an options file for MySQL to store the database connection credentials. You will learn more about it later in this lesson. The credentials can include the database name, username, and password, and are stored in a separate configuration file. Inside the settings.py file, the MySQL connection reference looks for the connection file in the directory etc/MySQL. And notice that this is not within the Django project. This is a deliberate security measure. You should note that the settings can also be updated directly in a Django settings.py file, but it is not recommended to be done in the production environment. While Django creates all the tables based on the models you have from the migration scripts, the initial setup requires you to manually create the database. Creating a database requires a connection to the database itself and sufficient permissions for authentication and authorization. It's important to remember that you must keep the database secure by assigning security roles and using strong usernames and passwords. As a developer, you need to be aware of potential security risks, and one significant risk is the security of the credentials of your database. Allowing someone to know or access the username and password of your database can have major consequences. You might find it hard to gauge the advanced functionalities available in Django while using databases. However, the use of Django with MySQL in a full-stack application is a well-accepted industry standard. The ease of scalability and configuration options available make it a good match while building robust and secure applications in full stack. MySQL is one of the world's most popular and widely used database engines. It's open source, very performant, and works with both small and larger scale web applications. In this video, you'll learn how to use MySQL as the back-end database engine for your Django project. Open the terminal and come to your Django project directory. If you are using pipenv, activate the virtual environment using the pipenv shell. To avoid dependency conflicts, you should always use a virtual environment for your Django projects, and pipenv is a great tool to manage your dependencies in the virtual environment easily. Django needs a package called MySQL client to communicate with the MySQL database. To install this package, apply the following command in the terminal inside your project directory: pipenv install MySQL client. If you're not using pipenv or configured your virtual environment manually, use pip or pip3 or your preferred package manager to install the MySQL client package. For example, pip install MySQL client or pip3 install MySQL client. Now connect to the MySQL server from the terminal using this command: MySQL u root p. If MySQL is running on a different port number than 3306, for example 3307, you need to specify it as well, like MySQL u root p 3307p. By default, the host name for MySQL is localhost. If it is different in your computer or server, you can specify it with a h switch, like this: MySQL u root h 127.0.0.1p. Now create a database called Little Lemon in the MySQL shell using a create database command. Create database Little Lemon. You can apply the command show databases to see if the database was created properly. This command will display all the databases available in your current MySQL setup. You're done here. Exit the MySQL shell using exit command. Now, return to your Django project directory and open the settings.py file. There is a section named Databases, which is currently configured to use the SQLite database that comes with every Django project. In this line, where it is mentioning SQLite 3 to use as the database engine, Replace SQLite 3 with MySQL. Write the database name as Little Lemon. You need 4 extra settings to connect to the MySQL engine. These are host, user, password, and port. For host, write localhost or the host name your MySQL setup is using. For example, 127.0.0.1. The default username for every MySQL setup is root. So use that as the user. If you created a different username for your database, then use that username. Just note, never use the root user in the production server because root user has full access to every database and MySQL settings, and any misuse could cause serious damage. For the password, write the password of this database username. And finally, if the MySQL engine is running at the default port number, 3306, you don't need to specify it. But if it's running on a different port, for example 3307, you can write it like this. And you're done. It is really simple. Now it's time to check if everything is working perfectly. Return to the terminal. Inside your project directory, make migrations using python manage.py make migrations, and then run the migrations using python manage.py migrate. If the MySQL setting is correct in the settings.py, you can see the migration is running successfully. Congratulations, you have successfully connected your Django project to MySQL. Now let's connect to the MySQL shell one more time to check if Django migration really created those tables in the MySQL database. Select the database you created previously using this command. Use Little Lemon. Now list the tables created by migrations using this command, show tables. Excellent, now you can see the list of the tables created by Django migrations. In this video, you learned how to successfully connect to the MySQL database in your Django project, and you learned how to use the MySQL shell. You also learned how to change the settings in the settings.py file to make a successful connection if your MySQL setup runs with a different host name and port number. Forms may appear to be simple components of web development, and therefore an aspiring developer like yourself might not be so interested in learning more about them. However, forms are in reality the primary elements of user interactivity on the web. It is the backbone of data exchange. For example, the comments you make on social media platforms are effectively done via forms. So are reviews users give on restaurant apps. By now you should know that the front-end component of full-stack applications generally involves HTML, CSS, and JavaScript. However, Django provides alternatives to this conventional approach to creating forms. Other than templates, Django provides an easy way to generate forms using a form API and model form class. This video will give you a quick overview of what you've learned about forms, model forms, and how they can be generated using the Django framework. Developers use the form class in Django to automatically generate HTML form elements from classes. In Django, the most common form submission is a POST request, which will send the data via the POST body. The server-side code handles the incoming request and processes the data on the back end. In comparison with creating forms using HTML, Django makes it much easier to work with forms, especially large forms. Let's explore an example. Suppose you create a basic form using HTML to submit a name. You can use a label to display text describing what the input should be. The input set to the type text accepts input from the end user. In this example, the input stores the name. The second input of the submit type is a button that displays the text, send name. When the button is pressed, the action will be triggered to make a POST request to be processed by the order view. And this is all defined in the form action and form method attributes. While this process works well, the code can become tedious and complex when dealing with large forms. For example, forms can have many different ways of gathering data with conditional flows. Also, designing forms in this way can lead to errors because each form element's name or ID attribute needs to match what the back-end code expects. To assist developers with form creation and processing, Django uses a form class. In this class, you can define all the expected attributes that will be passed down in the request. This means you can use a form class to represent the expected attributes and render the form elements in HTML. For example, the submit name form can be represented by creating a class. Let's step through this code line by line. First, you create a class called nameForm, which accepts a parameter of forms.form. This is essentially what is being passed in the form itself. Next, you create a variable called yourname, which is assigned forms.char field to represent the HTML input element. Notice that you also can set some validation by setting the attribute max length value to 100. Finally, when the nameForm class is rendered, it's rendered to a view containing the HTML form code. For developers, the advantage of creating forms in this way is that it's much easier to manage any changes to the form. Instead of worrying about the names of inputs matching with the server-side code, this is handled entirely by the form class. Let's explore another type of form used in Django, which is the model form. Model form goes one step further by providing a way to store data too. Sending data to the backend using the post method requires you to persist the data somehow. A model in your application will represent the table to store this information. So the model itself can then directly be converted into a Django form. The process of creating a model form, a special class in Django, is similar to that of separately creating a model and a form. Model form provides a means to save received data as a response directly to the database. There are three main processes involved when creating a model form: creating a model form, and configuring the view for processing form data. Let's take an example. Say you want to create a logging form for the employees of the Little Lemon restaurant to log their work hours. Let's say you created a model called logger and passed the models.model argument to it. The class will consist of three attributes: first name and last name that have form fields set to char field, and a third attribute called timelog, which has time field as its form field. Each of these attributes corresponds to an HTML element in the form. By convention, the user-defined form classes are stored in a forms.py file in the app's package folder. Inside the form class, its attributes, and methods in the Django.forms module are used as a base for a user-defined form design. Let's examine the form closer. The logger model is converted into a form by the Django model form class. You import the model you want to bind with your form. Next, you create an instance of that form passing the models.model form as an argument. Finally, you add implementation details for it using a meta class. Note that instead of having separate classes for form and model, you have just one that inherits the model form and implements it. Since data exchange via a form involves sending form data back as a response, you also need to add some implementation details about the post method inside the view. Let's now examine how you can do this. In the view called FormView, an instance called FormOfTheLogForm class is created. When a post request with values passes validation, these values are saved to the log form. Overall, once the migrations are performed and you run the server, the form input data gets processed by the view and updated in the database. The attributes of a form are field class objects. These fields correspond to the HTML elements that eventually render on the user's browser. For example, the forms.char field is translated to HTML's text input tag. Out of the many available form field types, some of the most frequently used are char field, which translates to the HTML text input type; integer field, which is similar to a char field but is customized to accept only integer numbers; and float field, which is a text input field that validates if the input is a valid float number. There is also the file field, which is like the file upload input type on the HTML form. The email field is a char field that validates if the text entered is a valid email ID. And lastly, the choice field is used to emulate an HTML form select element. While building forms may be a relatively simple process, there are several different options and coding languages that can be used to create them. Selecting the appropriate type of form is important for both the user experience and efficient data processing. JavaScript, as you have learned, is a scripting language that dynamically updates data, multimedia, and other components on a website. While you can use JavaScript and Django in an infinite number of ways to develop a full-stack application, developers primarily follow one of two major approaches: client-first or server-first. In client-first architecture, front-end is the highest priority. When following this architecture, you first build applications using JavaScript and other frameworks such as React and processes such as templating and URL routing. Django is then later used primarily for coding the interaction with the database and utilizing utility apps such as the DRF. On the other hand, with server-first architecture, you start by building the components of an application using Django APIs before you work with the front end. Fortunately, Django makes it possible to add JavaScript components inside HTML templates. The missing gaps can then be filled using JavaScript, Ajax, and simple event handling mechanisms to build a solid foundation for web applications. A back-end developer will prefer taking a server-first approach. While there are several supportive libraries for JavaScript, you can build a simple form by just using the native JavaScript functionalities. This video will demonstrate how to use JavaScript inside a Django application to process a form. By now you should know that the comments users add on websites are effectively done using a form. So this example will walk you through the steps to create a comment section for the Little Lemon food blog following the server-first approach. Let's briefly outline what the process will involve. The form will be updated by an API endpoint, which uses a post method to send a request to the Django view. The entered user data, or comment, is then added to a MySQL database, which was created earlier using models in Django. So, using the DOM event type in JavaScript called addEventListener and fetch API in JavaScript, you make a post request to the form's action URL before converting it into JSON data and sending it to the database. Let's get started. You have created your Django project and app and configured the URLs. Additionally, you have already updated database settings for MySQL inside the settings.py file with blog_db as your database name. You have set the username and password to root for simplicity. It is not good practice to assign them the root value in production environments. Next, let's open the models.py file. The model user comments consists of 3 attributes: the first and last names and comment with char field as their form field. Next, go to forms.py file to create a model form called comment form from the user comments model. This will be the form you'll use in your Django template. Then go to the views.py file and add the required imports, such as the model, model form, and JSON response class. Now create the view function called formView and pass the request object as an argument. You're going to use this view function for 2 things: rendering and processing the form data, and then sending it to your model. First, create a form object from the comment form model form. Create a condition so that it updates the form object with its contents if the request method is post. In other words, the form data that the user has entered. If the form data is in a valid format, you create a new variable called CD that is assigned the result of a clean data function on the form object. Clean data is a form function in Django that helps with data normalization. Now you need to send this data to the user comments model. Do this by creating an object variable called UC and assign it the user comments model class. Individually assign the values that you received from the post method to the attributes in the model. Finally, call the save function on the UC object to update the model data. To complete the code of the view, return the render function from it and pass the arguments request blog.html and the form data as a dictionary. Note that the dictionary object that was passed will be used to render the model form in the template. Moving on. Create a template called blog.html inside the app, matching the name you have passed inside the render function. Open the file and make sure the basic HTML tags such as title and heading are updated. Next, add the form that you passed using render function inside the template. Use the Django template language as a paragraph denoted by dot as _p, which must be added inside the HTML form tag. Now create an HTML script tag to add the JavaScript functionality. Create a constant called form and assign the getElementById function with form passed inside it. This helps access the specific form element from the HTML code. Next, add an event listener function called addEventListener and pass a function inside it called submitHandler. SubmitHandler is where you'll be adding the form handling mechanism next. First, add a failsafe mechanism by calling the preventDefault function. Call the fetch function and pass some arguments inside it. This line makes a post request to the form's action URL. The dot that follows is a promise made by the fetch function that represents an eventual completion of an operation that may be asynchronous. Inside it, pass the response object that is first converted into JSON. In the next dot, then function, the JSON data gets processed. If the processing is completed, JavaScript will send a successful submission alert. Finally, add a line to reset the form after submission. Close the HTML and body tags to complete the code and save the file. To keep the alert in sync with the code in Django, open the view.py file once again and return a JSON response class that will post the success message. Let's save this file again and perform the migrations. Note that the user comments model created from the model will also render as a form. Time to test it. Add a command to run the server and go to the specified URL by adding the suffix quotation mark /blog closed quotation mark to the code. Notice the form that you have created contains the first and last name and a text field for adding a comment. Enter some details and press the Submit button. When you press the Submit button, notice how JavaScript sends a text alert displaying success. Let's close this alert and add another comment. Let's review what's happening. The couple of entries you have added will be updated in a table called My App User Comments inside the book DB MySQL database. And that's it. Now you know how JavaScript, with the help of functionalities such as Fetch API and Event Handler, can be used for updating form data without refreshing web pages inside a Django project. You've come to the end of another module, and you've done a great job so far. A lot of the content in this module was to review knowledge and skills you have already covered in other courses to help you be successful in this one. Let's go through the main points from this module. You started off the module with a recap of what you know about Django. After all, this module is about the full stack using Django. Then there was another recap, this time for APIs, which was also important since you'll be working on an API project. Next, you learned about doing an environment check. This included learning about the tools you need to create your API project using Django and DRF. Furthermore, you also learned about the virtual versus global environments, using pipenv, installing MySQL client library with pipenv, as well as testing a MySQL connection. After this, you had another recap, this time about databases and MySQL to prepare you for setting up a MySQL database on a Mac. Here you learned how to use Homebrew to install a MySQL client and server on Mac OS, and how to connect to MySQL from the command line. Following this, there was another recap, this one about models and migrations. This recap included important information like why you need models in Django, how to create models in Django, how to create database tables using migrations, and how to update tables using migrations. After this, you learned how to configure Django to connect to MySQL, and you had the opportunity to practice it in a lab. At the start of the final lesson of the module, you reviewed what you know about forms and model forms. This is an important topic since forms are the backbone of data exchange, and you can create both forms and model forms using the Django framework. In fact, Django makes it easy with a form class to create and process forms. And what's more, model form provides a way to store data too. Remember that there are 3 processes involved when creating a model form: creating a model form, and configuring the view for processing form data. In the video, Fetching Data Using JavaScript, you learned how to use native JavaScript functionalities to update a form inside a Django project. JavaScript helps you process simple forms and takes care of the preliminary requirements in templating with the help of libraries such as Bootstrap. It also performs functionalities such as input validation and form reset. Lastly, you practice submitting a form with JavaScript. And that was the end of the module about the full stack using Django. Hope you're excited for the next one. Congratulations on making it this far. You now know about working with databases, writing your back-end application using Django, and creating APIs, as well as front-end applications. Now it's time to learn about deployment and server and serverless cloud computing. First up in the deployment process, to run a production application in the cloud, you need one or multiple servers to upload your application and link them to your domain. This process of uploading code and data to the servers is called deployment. Some people use manual deployment, while others use automated deployment. With the manual method, you need to manually upload everything using File Transfer Protocol, FTP, Secure File Transfer Protocol, SFTP, or tools like rsync. However, automatic deployments are easier if deployment is properly configured with a version control system and build tools. It starts when the developer makes some changes and pushes code to the repository. The build tools receive the signal and create a build environment identical to the production environment. It runs the tests to ensure everything in your code is working correctly. If everything is okay, the build tools connect to the server where your files will stay and upload your code. There are two essential terms involved in deployment. Continuous integration, or CI, is the process of imitating the development environment and then running the tests to ensure your code is okay. The uploading process is called continuous deployment or continuous delivery, CD for short. These are often used together. A typical workflow of CI/CD involves these steps: code, version control, build, test, and deploy. Tools that you can use for these steps are Jenkins, CircleCI, and GitHub's CI Actions. But if no test runner is involved, it's only continuous deployment. Let's move on to hosting your application. To host your code and database, you need to follow one of two approaches: server or serverless. The word serverless suggests that no physical servers are involved, but that's not accurate. Both methods require physical servers, but the deployment process makes them significantly different from each other, and both have their advantages and disadvantages. Let's examine those. First is the server approach. Hosting companies sell two types of servers: dedicated and virtual servers. Each layer of your application is hosted on one or multiple servers. A dedicated server is a computing unit available for only your use. You have full access to this unit and can add RAM and storage whenever necessary. However, only some applications need lots of memory and computing power. Some can run with just a few megabytes or gigabytes of RAM and 1 or 2 processor cores. In such a case, a dedicated server doesn't make sense because the remaining resources stay idle and you waste money on bills. This is where the virtual servers come into play. Using hypervisor software, the dedicated server is virtually split into multiple servers or virtual machines, separate from each other. You can assign fixed resources to each of these servers or allow them to work in a relatively shared fashion where they can occasionally access extra resources that are sitting idle. An advantage is that you can configure each virtual server with different operating systems and tools, as they will not conflict with each other. So one virtual server can host the application code while another deals with the database. The disadvantage is that you have to manage everything by yourself, which can be tedious and time-consuming. This is where serverless is different. With a serverless approach, you don't have to configure anything. Not for storage, CPU, or creating a production environment, and not even for memory allocation. The advantage is that everything is there and properly managed by the serverless provider. A serverless provider is closely integrated with the version control system. Whenever you push code, the serverless provider starts working automatically. It builds the code, runs the tests, deploys your code in their servers, and provides you with a URL to access the hosted application and database. You don't manage or configure any servers, and you don't have to worry about loads. You just push your code and access the application. For this reason, this approach is called serverless. Serverless providers take care of everything and ensure your application is up and running correctly. And they charge you by the amount of computing power, memory, storage, and bandwidth your application consumes. But since serverless bills by usage, any unmonitored consumption can cause a big spike in monthly bills. Another disadvantage is that when you use serverless providers, you are locked to the vendor's environment and conventions. And serverless vendors do not adhere to universal code requirements. So moving apps to another vendor requires some code changes. In this video, you learned about continuous integration and continuous deployment. You also learned how to host your application in the cloud using server or serverless technology. This knowledge will help you to make your future apps available to the public or authorized people only. Now that you have an idea of what application deployment is, let's dive deeper into virtual servers and containers. Both technologies are used to host your applications and run them isolated from each other, but they work very differently. First is hypervisors, which are software used for virtualization. As you learned in the previous video, a dedicated server can be split into multiple virtual servers, also called virtual machines or VMs, using hypervisor technology. Each of the virtual servers runs separate operating systems and applications, and each works like an individual computer. And as such, they have dedicated IP addresses to communicate with each other. There are primarily two types of hypervisors involved in creating virtual machines. One is a Type 1 hypervisor or bare metal hypervisor. The second one is a Type 2 hypervisor. The Type 1 hypervisors are a software layer that works directly with server hardware, and because of this, they are more efficient when it comes to resource management. Setting up a Type 1 hypervisor is a complex process, but applications running on a Type 1 hypervisor are usually faster because they have dedicated resources assigned to them. KVM is one of the most widely used Type 1 hypervisors, and it's open source. On the other hand, a Type 2 hypervisor works mostly on top of an operating system and is usually slower than Type 1. But managing a Type 2 hypervisor is simpler than a Type 1 hypervisor because they come with a simpler management console. And you don't have to directly deal with the hardware for Type 2 hypervisors. Oracle VirtualBox is one of the most popular and widely used Type 2 hypervisors. It's open source software and available for free. Let's move on to resource sharing and how that works with virtual servers. Virtual machines can be configured to use dedicated computing resources or share them. For example, a dedicated server with 3 terabytes of storage, 12 gigabytes of RAM, and 6 processing cores can provide its resources entirely to whichever virtual machine might need it. Alternatively, it can be configured to split its resources equally between all virtual machines. If there are 3 virtual machines, each of them can use 1 terabyte of storage space, 4 gigabytes of RAM, and 2 processor cores. But take note, while dedicated resources ensure availability, they can also sit idle and lead to wastage. Say, for example, each virtual server gets a dedicated 4 gigabytes, but a smaller application hosted on one of them only requires 1 gigabyte. A considerable amount of memory remains idle. The same goes for the CPU and storage. And since these resources are dedicated, other virtual machines cannot access these resources even when they are free. On the other hand, what if you have a single dedicated machine, but you need more resources than it can offer? This is where shared virtual machines come in. They can use the resources assigned to them, and they can also use extra resources from shared machines when it's available. However, such usage is monitored, and continuous overusage is considered abuse, and it can lead to termination of the server if it's happening with a public provider. Now let's move on to containerization. It takes time to set up and configure whether a Type 1 or Type 2 hypervisor is used, and you also need to install an operating system on a virtual machine. What if you can remove hardware and the operating system from the equation and focus only on your application and its dependencies? This undoubtedly makes things easier, and you can spend more time on development. That's what containerization is for. Containerization technologies help you pack your application and their dependencies into container image files. This enables you to run them as containers using a container engine, regardless of the operating systems or hardware. A container can pack single or multiple applications with all dependencies, or you can distribute your applications across multiple containers and configure them to correctly work together using a container engine like Docker. For efficient management, you should keep your containers lean and stick to one process or application per container. Since container engines abstract the operating system layer and containers don't run their own operating system, they are smaller in size, run faster, and are more manageable than virtual machines. Containers are also very portable and you can deploy them quickly. Docker is one of the most popular and widely used container engines, and it's available for free. There are a few terms you need to know about when dealing with containers like pod, cluster, and node. Let's explore the meaning of these and other terms. When a group of tightly coupled containers share the same resource and work together to solve a particular problem, it's called a pod. And a physical or virtual machine that runs one or multiple pods is called a node. Whereas multiple pods and multiple nodes, which could be related to each other or work completely independently, are called a cluster. Finally, there's the management, deployment, networking, and scaling of these containers, known as container orchestration. Kubernetes, or K8s, is one of the most popular and widely used container orchestration solutions used by developers worldwide. Hosting your application can be challenging. In this video, you learned about technologies used to host your application in the cloud. You learned about different virtualization tools to create virtual servers or machines. You also learned about containers, which can pack your application and all its dependencies together. And finally, you learned some key terms used in the world of containerization. You are now well placed to successfully host your applications in the cloud. Cloud computing is an on-demand solution that hosts applications on the internet and makes them accessible to everyone. It also enables people to use the computing resources hosted by a cloud provider and generate solutions quickly. In this video, you'll learn more about cloud computing. Imagine you create an application that takes a single computer 8 hours to process. That's a long time. To save some time, you can either purchase a more powerful computer, or you can purchase more than one computer and distribute the task across multiple computers to solve it even quicker. But what will happen after the solution is generated? Most likely, the computers will sit idle until you need them again. This kind of expense can be very unrealistic, and you can avoid it by leveraging cloud computing. That's because you can use the computing units in a cloud provider on demand. You use them for a specified amount of time, and you only have to pay for what you use. This way, you can use extremely powerful computers with the latest CPUs, GPUs, massive memory, and storage without needing to purchase physical computers that are very expensive. Cloud computing providers offer different computing resources that can be used to host applications or solve a problem on demand. There are different types of cloud infrastructure that are used to deal with different kinds of problems. Let's examine 3 of them. First is the public cloud, which is for everyone. You can create an account and start using the service anytime. This cloud infrastructure works in a pay-as-you-go style. The public cloud providers host the servers and create and maintain the network. You can use these computing resources anytime and discard them when your work is done. You will only be charged for what you use. There are several benefits to using the public cloud. Since these are mostly managed services, you can spend more time creating and running your application. It also has on-demand pricing and quick availability. And another benefit is scalability. You can quickly add a computing unit or node to your infrastructure to balance the loads. Some cloud providers even support auto-scaling. This means they will automatically deploy extra nodes when the traffic spikes and then remove these nodes under average load. Starting an application on the public cloud can be cheap. However, as your usage grows, it can become expensive over time. Second is the private cloud. Unlike public clouds, which are accessible to everyone, private clouds are not. It's a privately hosted cloud infrastructure used by applications that deal with sensitive data that require more security. A private cloud ensures that only authorized people can access the system. At the same time, it offers everything necessary for internal applications to scale and perform properly. A private cloud is for the most part a tailored solution and comes with a subset of features compared to public cloud providers. Its main benefits are better security, control, scalability, and reliability. But since everything is hosted and managed by yourself, it can be costly to start with. Last is the hybrid cloud. It's a mixed cloud infrastructure where a part of it is hosted on a private cloud and some services are hosted on a public cloud. The public cloud remains connected to the private cloud so that the application can work correctly. The benefit of this type of cloud is that it can be less expensive than a private cloud because it also uses a public cloud. However, setting up a hybrid cloud can be very complex and may take a lot of time. In this video, you learned about cloud computing and how it can help you to reduce costs. You also learned about public, private, and hybrid cloud infrastructures and their advantages and disadvantages. Now that you're familiar with cloud computing, let's examine some key elements and services offered by public cloud providers and how they can benefit your applications. First up are computing units. This is one of the most popular services offered by public cloud providers. Computing units are virtual machines available for on-demand deployment. They are used to host a web application or run a program to solve problems. You can pick computing units from mainly two groups, cores and memories. And the cloud computing units can be resized, which means you can upgrade or downgrade the number of processing cores or memory as needed. For complex programs like data analysis or machine learning, most cloud providers offer a variety of processor cores and memories, and some even offer use of GPUs. Since you're charged only for what you use, you can deploy a powerful computing unit when you need it. Let it run as long as required, and then delete it. And what's more, you can install your preferred operating system and applications in these cloud computing units. Some of these computing units come with volatile storage, which means everything you store in it will be gone when the machine reboots. In such cases, you must always equip your computing unit with a permanent storage solution. This will be covered later in the course. Next is storage, a significant benefit of using cloud computing. You can purchase storage, keep your data as long as you want, and then delete it whenever necessary. Cloud computing providers offer storage solutions in a few ways. You can purchase gigabytes or terabytes to store your application files or personal data. It works just like a regular hard disk, but the risk of data loss due to hardware fault is nearly zero. This is because cloud providers automatically back up your data in redundant storage. Another storage solution offered by public cloud providers is called object storage. In object storage, you get an API to upload and download your files, and that's all. You can store small or massive files in object storage. And what's more, you can also make these files available to anyone for a certain amount of time with a timestamp signature. Cloud providers give you a unique URL to access your file, and that link automatically expires after the duration you specified in the signature. Now let's move on to databases. Most public cloud providers offer SQL, NoSQL, or time series databases to store your application data. Examples of SQL are MySQL, MariaDB, and PostgreSQL. And examples of NoSQL are MongoDB, Cassandra, and DynamoDB. Whereas examples of time series are InfluxDB and Prometheus. Tuning a database can be tricky, and scaling it can be tedious and requires a lot of effort and careful supervision. With cloud computing, these issues disappear. Cloud providers offer fully managed database solutions compliant with popular database engines like MySQL, MariaDB, or PostgreSQL, so no change in the application code is necessary. Since these are managed solutions, you can allow these databases to scale automatically as they grow, and they'll be able to withstand substantial traffic loads without extra effort. Some cloud providers also offer in-memory database solutions, which are great for caching or super fast data operations. Cloud providers can also offer specialized solutions to deal with huge amounts of data or big data. With cloud computing, you can deploy a single database node or multiple ones in just a few seconds and link them to your applications. Finally, there's machine learning, which requires powerful computing units and GPU for data modeling and training. But this can be very expensive if you purchase physical hardware. However, with cloud computing and its on-demand pricing model, you can start using machine learning at a cheaper cost. Cloud providers offer the latest hardware and software solutions that are efficient for machine learning, natural language processing, voice processing, and so on. For machine learning, cloud computing is a perfect and affordable solution. Cloud computing is an excellent solution that allows you to spend more time on application development instead of managing hardware and infrastructure. In this video, you learned about some essential services offered by cloud computing providers and how they can help your application development lifecycle. Imagine your application is featured on a famous blog, and as a result, many more visitors are coming to your site. Or you've received many signups after a successful social media campaign, and your database is growing fast. If your application is not ready to handle such loads or sudden traffic spikes, the web server or the database server will fail to handle requests. They will either be extremely slow to respond or go down. That is why your production server must be scalable to sustain such loads or be responsive as your users grow. In this lesson, you are going to learn everything about scalability. Scalability is the process of resizing your production infrastructure to withstand the load as it goes up or down. Sometimes the load could be sudden, otherwise it will continue to grow as your application gets bigger and starts to have more users. Usually in a production environment, the main bottlenecks are the web server and the database server, which need to be scalable. And there are two types of scaling, vertical and horizontal. Let's examine them in detail. Under load, the web server and databases mostly fail for two reasons: lack of resources, like CPU and RAM, or incorrect configuration, which prevents them from using available resources. If you are failing due to the lack of resources, it's a comparatively easy fix. The solution is to add more storage, RAM, or processing cores to the virtual machine or upgrade the physical processor. This process of adding RAM or CPU or storage is called vertical scaling. But there is a problem with vertical scaling. You cannot add an infinite amount of processor cores, RAM, or storage in a physical machine. How many resources you can add depends on the hardware configurations. Once the limit is reached, you cannot scale anymore. Moreover, adding physical hardware like this can be very expensive and unrealistic over time. Vertical scaling is quicker than horizontal scaling and has easier configuration. Therefore, it looks appealing as an easy fix, but beware of its limitations. It can be costly over time or when it needs repairs. And always keep in mind that you cannot scale infinitely with vertical scaling. However, there is another type of scaling that overcomes these issues, and that is horizontal scaling. In fact, it's considered more efficient and cost-effective. In this process, you add nodes or virtual servers as the load goes up and remove the nodes when they go down. For example, if one web server can handle 2,000 requests per minute, to withstand the load of 10,000 requests per minute, you need to add 4 extra nodes to the web server. So 5 nodes will be capable of handling 10,000 requests per minute without any issues. The same thing goes for the database. You can use database replication or database clustering to create multiple database nodes as the load grows. And when the load returns to normal, you can remove those nodes again. An application with a proper horizontal scaling setup can be scaled to handle a tremendous amount of load. It's infinitely scalable with horizontal scaling. However, it's not a plug-and-play process. Configuring your application infrastructure to be horizontally scalable takes time and effort. Finally, let's discuss auto-scaling. Some cloud providers offer an excellent auto-scaling solution with no manual intervention or extra configuration. When you turn on auto-scaling, the cloud provider automatically adds or removes computing nodes, memory, or other resources to keep the application sustainable and healthy under load. With this feature, you can save a lot of time and ensure better uptime for your application. In this video, you learned about scalability and the pros and cons of vertical and horizontal scaling. Load balancers help scale your application by evenly distributing loads on multiple nodes in a round-robin fashion or based on node health. You can use various load balancing techniques to reduce the pressure on your application infrastructure, and in this video, you will learn about them. Let's start with load balancing the web server. Your web server plays a vital role in accepting all HTTP requests, sending them to the backend scripts, getting the response, and delivering it to the client. The web server also receives requests to serve static HTML, CSS, and JavaScript files. Many cloud providers offer load balancing services. Using these, you can create multiple web servers with the same application code and link them to the load balancer. The load balancer then accepts all HTTP requests and sends them to the web servers. This load distribution can happen in two styles, round-robin and health-based. In the round-robin style, the load balancer distributes the load equally on all web servers. But there is a problem. Not every request is the same. Some requests take a fraction of a second to finish, and some take longer. In a round-robin load distribution model, if a web server is already working on a request, it may receive subsequent requests and then take a long time to process those requests. There's a better way to deal with this problem. Some load balancers are configured in a way that can monitor the load on these web servers and then distribute the load only on those nodes which are available and not already loaded. This is called health-based load balancing and works better than round-robin style. You can use a reverse proxy to perform load balancing. The web server serves everything, including application URLs, API calls, and static files. A reverse proxy can be configured in such a way as to serve the static files by itself and forward the application's specific URLs and API calls to the web server. Static files includes HTML, CSS, JS text files, and images. This technique is widely used and improves the performance of your web server by reducing the number of requests the web server has to handle. Similar to serving the static assets using a reverse proxy, you can completely offload them to an external content delivery network, or CDN. This can speed up your application's page rendering time because CDN services create multiple copies of these static files and serve them from the client's nearest data center. The database is one of the most crucial parts of every web application. A well-tuned database server can handle a huge load. Scaling a database is more complex than scaling a web server. Sometimes vertical scaling helps, but horizontal scaling has better sustainability. There are two popular techniques for scaling databases horizontally. The first one is sharding. This is when a large database is split into multiple chunks and one database server holds one chunk. One extra database is needed to keep track of these chunks for better lookup. With the master-slaver replication approach, the whole database is replicated on multiple servers. One works as a master server, where the data modifications happen. As soon as something changes, the master server writes those changes on other servers, which are called the slave servers. All the read requests are evenly distributed to these slave servers. This way, multiple slave servers can handle more SQL queries and still remain healthy. Most cloud providers offer managed database servers where they internally balance the loads and process a massive amount of data without creating trouble or going down. Using this managed database service, the developer remains worry-free and focuses on development and business growth instead of tedious infrastructure management and DevOps processes. The load balancing techniques discussed are considered public load balancing because they are directly dealing with the external client requests. Private load balancing is sometimes necessary where heavily loaded internal non-public applications or microservices are communicating with each other over private IP addresses. In this video, you learned about load balancing. You learned about different public load balancing techniques for the web server and databases, and about private load balancing. You have reached the end of this module about production environments. It's now time to reflect on the key concepts and elements you learned about. Let's get started. First, you learned about web server environments. You learned that the process of uploading code and data to servers is called deployment, and that it can be manual or automated. Two essential terms you should remember are continuous integration, or CI, which imitates the production environment and runs tests, and continuous deployment, or CD, which is the uploading process. You also learned that hosting applications can be either server or serverless. With the server approach, a dedicated server or virtual servers provide access to idle resources, but it has to be managed manually. With serverless, you don't have to configure anything as everything is provided and managed by the serverless provider. Next, you learned about virtual machines and containerization. There are two types of hypervisors, Type 1 and Type 2, that can split a dedicated server into multiple virtual ones. Type 1 works directly with the hardware and it runs fast, but it's complex to set up. Type 2 works on top of an operating system, which makes it slower, but you don't have to deal with any hardware. You also learned about resource sharing, where you can either use a dedicated server that's potentially wasteful, or virtual machines where there are shared resources and therefore no wastage. There's also the concept of containerization, which allows you to pack applications and dependencies in container image files that can run anywhere regardless of operating system or hardware. There are some key terms related to containerization that you should remember. A group of connected containers sharing the same resource to solve a problem is called a pod. Multiple pods, related or working independently, are called a node. And container orchestration is the management, deployment, networking, and scaling of the containers. Following this, you learned about PaaS, which is a platform as a service that gives you everything you need to run an application, much like cloud service providers. You also learned about SaaS, which is software as a service that solves a particular problem and provides an API to use it. DBaaS is a database as a service and provides only database solutions. Lastly, you learned about IaaS, or infrastructure as a service, for creating an infrastructure with servers. And self-hosted means that everything is hosted on your server. You create the infrastructure and networks, and they have to be managed by you or your team. Next up was a lesson about cloud computing, where you learned that there are 3 different types of cloud infrastructure: public, private, and hybrid cloud. And all 3 offer you access to high-powered machines. A key element of cloud computing is a computing unit, which is virtual machines that are available for on-demand deployment. You also need to buy storage, and you have the option to buy gigabytes or terabytes, or you can use object storage, which is when an API uploads and downloads your files. Cloud providers offer fully managed database solutions that scale automatically, freeing up your time and saving you effort. Another key element of cloud computing is machine learning, which requires a lot of computing power, and it's cheaper with cloud computing because you don't have to buy physical hardware. Then you learned about networking in the cloud, where you can use either public networking or private networking, where cloud units are not public-facing and only communicate with other units in the same application. Following this, you had a lesson about scaling in the cloud, where you learned that there are 2 types of scaling: vertical and horizontal. With vertical scaling, you add RAM, CPU, or storage to a physical or virtual machine. But there's a limit to how much you can add, and physical hardware is expensive. Horizontal scaling, on the other hand, adds nodes or virtual servers as the load goes up and removes nodes when they go down. This means you're not limited like you are with vertical scaling, and costs can be kept down. Cloud providers offer auto-scaling, which saves you a lot of time because no manual intervention or extra configuration is needed. You also learned about load balancing, which includes load balancing the web server, the data server, and the cloud. With the cloud providers offer services where they internally balance loads, whereas you have several options to load balance your data server by horizontal scaling, either by using clustering or master-slave replication. And when it comes to load balancing the web server, you can use either a round-robin approach or a health-based one. Another option is to use a reverse proxy to perform load balancing. Lastly, you learned about how content delivery networks, or CDNs, can improve scaling by caching and serving static assets in the cloud, and how CDNs can determine the nearest point of presence, which is a server where static assets are stored. You covered a lot of ground in this module, so some congratulations are in order. You should reward yourself with a break before you dive into the last module that's all about the final project. You've almost reached the end of the full stack course. What's left now is to demonstrate the skills you've learned in the course in a project comprised of 3 separate but connected labs, and then you will complete the final graded assessment quiz. The labs will assess whether you are able to connect the back end of an app to MySQL, set up a booking API, and have an app display available booking times. But before you get to that, let's recap what you've learned up to this point to help orientate you for the final project and quiz. The labs and graded quiz will test everything you've learned in the course, so use this recap to check which parts of the course you're unsure about and have to review again before you continue with the rest of the module. If you think back, you'll recall that Module 1 was an introduction to the full stack and what a full stack developer does. To be a full stack developer, you must learn everything that is required to create and deliver a functioning application. Thus, you learned about the different stacks: front-end, back-end, and data stacks. A full stack developer needs to be comfortable with all 3 parts of development to be successful. And such a developer should have some essential DevOps skills to build and deploy an application to production, staging, and development servers, as well as be familiar with a version control system like Git. Next, you learned about end-tier architecture. This is when an application's architecture is split into multiple tiers. The benefits of end-tier architecture are that it is easier to secure and scale an application and fix problems or add new features. Fixing and adding features are more manageable because each tier is separate and works independently. Finally, you reviewed what you know about client-server architecture, which included learning about the components of a client-server architecture and the role of clients and servers. In Module 2, you learned about front-end technologies, which include HTML, CSS, and JavaScript. In the HTML section, you learned how to create a well-formed web page, as well as form submissions and perform validation. You also learned about the different input types that are validated by the web browser on the client side. In the CSS section, you delved into CSS layouts and how to create them with grids and flexboxes. Layouts, for example, are critical to designing a good web page because they divide a page into different parts, making what the user sees more presentable. The lesson also covered how to work with CSS selectors, pseudo-classes, and pseudo-elements. Lastly, in this module, you learn more about JavaScript, which builds interactivity into web pages. When you use JavaScript, updates are displayed in real time on users' devices. You also learned about data types like string and number, and when you should use them. And you learned about event handling, which is a function in JavaScript that enables you to capture user input and process it to manipulate what's displayed to the user. Finally, you learned about front-end libraries and frameworks you can use to streamline your coding. In Module 3, you reviewed a lot of content from previous courses to make sure that you are well placed to succeed in this full stack course. Thus, you had a recap of Django, APIs, database and MySQL, and models and migrations to refresh your memory. You also learned about the tools you need to create an API project using Django and DRF, as well as how to fetch data using JavaScript and using it to query APIs. There were 2 important labs in this module. One about configuring Django to connect it to MySQL, and another one about submitting a form with JavaScript. These are important to review for the final project. The last module before the final project was about production environments. This included learning about web server environments and the concept of deployment, which is the process of uploading code and data to servers. Here you learned about 2 important concepts: CI, or continuous integration, which imitates the production environment and runs tests, and CD, or continuous delivery, which is the uploading process. You also learned about server and serverless. Server means there is a dedicated server or virtual servers that you can access to make use of idle resources, but it has to be managed manually. While serverless is when everything is provided and managed by the provider and you don't have to configure anything. Next, you learned about virtual machines and how you can use a Type 1 or Type 2 hypervisor to split a dedicated server into multiple virtual ones. Following this, you learned about containerization, which allows you to pack applications and dependencies in container image files that can run anywhere, regardless of operating system or hardware. Following this, you learned about PaaS, which is a platform as a service that gives you everything you need to run an application, much like cloud service providers. You also learned about SaaS, which is software as a service that solves a particular problem and provides an API to use it. DBaaS is a database as service and provides only database solutions. Lastly, you learned about IaaS, or infrastructure as a service for creating an infrastructure with servers. You also learned about the different types of cloud infrastructure and how they give you access to high-powered machines. A key element of a cloud computing is a computing unit, which is a set of virtual machines that are available for on-demand deployment. And you also learned about the storage options you have, where you can buy giga or terabytes, use object storage, or use cloud provider services that scale automatically. Then you learned about networking in the cloud, scaling in the cloud, and load balancing. Lastly, you learned about content delivery networks, or CDNs, and how they can improve scaling by caching and serving static assets in the cloud, as well as determine the nearest point of presence. This is a server where static assets are stored. And that's it for this review of the course's first 4 modules. Hopefully you now have a better idea of what you feel confident about and what content you should perhaps review again. Good luck with the final labs and quiz. Wow, you've made it to the end of the full stack course. Well done. You had to work hard to bring together the skills and knowledge you learned in all of the courses so far, so you should be proud of yourself. Bringing together multiple skills to build a full stack Django app is definitely an achievement. Let's do a quick review of what you learned in the course. After completing the course, you are able to show that you can connect an app's backend to MySQL, set up a booking API, and let the app display available booking times. In addition to this demonstration of your skills and knowledge, following your completion of the course, you should now be able to describe the architecture of the full stack, use semantic HTML to create web pages, create basic forms and use CSS to create layouts, update an HTML document using JavaScript, populate Django models from a MySQL database, query an API, and update an HTML document with the result. Identify the different hosting solutions for web applications, recognize the key components of a cloud computing environment, and describe the challenges of scaling web applications. Now you may be wondering what comes next in your learning journey. This is the 7th course in the Backend Developer program, and you are close to completing the full program. You have come so far and learned so much, but there's yet more to learn. Like in the next course on cloud computing, in this course you will learn about the different tools and systems involved in cloud computing in DevOps, and you'll explore popular cloud solutions and the benefits to cloud computing along with core cloud architecture concepts and approaches. Throughout the next 2 courses in this program, you'll continue to expand your skill set, and then you'll have the opportunity to bring everything together in the Back-End Developer Capstone project. The final course is coding interview preparation that will help you to be ready for an interview. And once you've completed all the courses in the Backend Developer program, you will receive a certificate. So now that you know what lies ahead, you can prepare yourself for the next steps in your learning journey. Good luck.